Hello there, and welcome. Tonight I want to take you somewhere far beyond the familiar glow of city lights, beyond the gentle pull of Earth's gravity, out into the vast and silent ocean of space where mysteries drift like ancient ships through an endless cosmic sea. Close your eyes for a moment if you'd like, and imagine yourself floating weightless in that perfect darkness. Surrounded by stars so numerous they blur into rivers of light, and in that profound stillness, I want to share with you a story that might just change the way you think about our place in the universe. It's a question that at first might seem too extraordinary to consider seriously, but as we explore it together tonight, you might find yourself wondering if perhaps, just perhaps, we've been looking at the evidence all wrong. What if the strange object known as Three-Eye Atlas, that silent visitor that passed through our solar system, was not just another wandering piece of cosmic debris, but something far more intriguing? What if it was the missing puzzle piece in humanity's long search for contact with other intelligences in the cosmos? Now, I know what you might be thinking. Here we go again. Another wild speculation about aliens and UFOs, another attempt to see patterns where there are none, and you're right to be skeptical. Science demands evidence, careful observation, and rigorous testing of hypotheses. But tonight, we're not here to make definitive claims or to convince you of anything. Instead, we're here to wonder together, to explore possibilities with the same gentle curiosity that has driven humanity to look up at the stars since the beginning of time. We're here to ask questions that matter not because they have easy answers, but precisely because they don't. As you settle in, perhaps adjusting your pillow or pulling your blanket a bit closer, I want you to consider that the universe is approximately 13.8 billion years old. If you compressed all of cosmic history into a single year, with the Big Bang occurring at the stroke of midnight on January 1st, our entire solar system wouldn't form until September, and humans wouldn't appear until the final seconds before midnight on December 31st. In this vast expanse of time and space, with billions upon billions of stars and potentially habitable worlds, the idea that we are alone seems almost mathematically impossible. And yet, the cosmos remains eerily quiet, at least to our ears. This silence, this apparent emptiness, is what scientists call the Fermi paradox. Where is everybody? If the universe is so vast and so old, if the conditions for life are not unique to Earth, then why haven't we detected any signs of other civilizations? Perhaps, and this is where our story begins to take shape, perhaps we've been looking in the wrong way, listening for the wrong signals, expecting contact to come in forms we recognize, rather than in ways we might never have imagined. Consider the possibility that an advanced civilization, one that has survived for millions or even billions of years, might communicate not through radio waves or laser beams, but through physical artifacts, through objects sent on long, patient journeys between the stars. These wouldn't be the sleek metallic spacecraft of science fiction, arriving with fanfare and obvious intent. No, they might be something far more subtle, far more patient, objects designed to drift through space for eons, waiting for the right moment, the right civilization to notice them. And this brings us to Three-Eye Atlas, that mysterious visitor that astronomers first detected in 2019. But before we dive into its story, let me paint you a picture of the cosmic neighborhood through which it traveled. Our solar system, you see, is not the isolated island we once imagined it to be. We're actually moving through space at tremendous speeds, orbiting the center of our galaxy every 230 million years or so. And as we travel, we pass through different regions of interstellar space, each with its own characteristics, its own population of drifting objects. Every year, perhaps every day, objects from interstellar space pass through our solar system. Most are too small to detect, tiny grains of dust or pebbles worn smooth by eons of cosmic wandering. But occasionally, something larger passes through, something we can see with our telescopes, something that makes us pause and wonder about its origins. These interstellar visitors are like messages in bottles, cast into the cosmic ocean by distant shores we may never see, carrying with them information about places and perhaps times we can only imagine. The night sky, as you look at it from Earth, appears unchanging, eternal. The constellations that you learned as a child are the same ones your ancestors saw thousands of years ago. But this is an illusion created by our brief human timescales. In reality, the stars are all in motion, all travelling on their own path through the galaxy. If you could speed up time, you would see the constellations slowly dissolve and reform, stars drifting apart and new ones taking their places. And between these stars, in the vast spaces we once thought were empty, countless objects are making their own journeys. Some of these objects are natural, pieces of planets that never formed, fragments blown off from ancient collisions, comets that escaped their home systems and now wander freely through interstellar space. But what if, just what if, some of these objects are not natural at all? What if some are artifacts deliberately launched into the void by civilizations that understood the patient nature of cosmic time? Civilizations that knew that the best way to explore the galaxy, to make contact with others, was not through brief, energy-intensive signals, but through physical objects that could survive the long dark between the stars. This idea isn't as far-fetched as it might initially sound. We humans have already sent 5 spacecraft on trajectories that will take them out of our solar system and into interstellar space. Voyager 1 and 2, Pioneer 10 and 11, and New Horizons are all destined to wander the galaxy for millions of years, carrying with them messages from Earth, artifacts of our civilization. If we, a species that has only had spaceflight capability for a few decades, have already created interstellar artifacts, imagine what older civilizations might have accomplished. The mathematics of interstellar travel are daunting when you think in terms of human lifespans, but they become quite manageable when you think in cosmic time. A probe travelling at just 1% of the speed of light, a velocity we could potentially achieve with technology not too far beyond our current capabilities, could cross the entire galaxy in just 10 million years. That sounds like an eternity to us, but remember, it's less than 1% of the age of the universe. A patient civilization, one that thinks in geological or astronomical timescales, might see the entire galaxy with probes, knowing that eventually, inevitably, some would encounter other worlds, other civilizations, and here's where the story becomes even more intriguing. These probes wouldn't need to be actively piloted or even powered for most of their journey. They could drift, silent and dark, conserving energy, waiting. They might be designed to activate only when they detect certain conditions, perhaps the radio emissions of a technological civilization, perhaps the specific chemical signatures of a life-bearing world. They could be sleeping, in a sense, dreaming electronic dreams as they float through the void, waiting for the right moment to wake up. Now, as you lie there in the darkness, perhaps you can feel yourself beginning to relax, your breathing becoming slower and deeper, your mind beginning to drift like one of these cosmic wanderers. There's something profoundly peaceful about imagining these patient journeys through space, these objects moving with no urgency, no deadline, just the steady, inexorable progress through the cosmos. Time means something different out there, in the space between stars. There are no days or nights, no seasons, just the slow wheel of the galaxy and the even slower expansion of the universe itself. When we think about alien contact, we often imagine dramatic moments, sudden revelations, the skies filling with ships or our radios crackling with unmistakable signals. But perhaps real contact, if it comes, will be quieter, more subtle. Perhaps it will come in the form of an object that at first appears completely natural, completely unremarkable, until we look closer and begin to notice things that don't quite fit. Patterns that suggest intention rather than chance. This is the lens through which we need to examine 3i Atlas, this mysterious object that passed through our solar system like a whisper in the dark. But to understand why 3i Atlas is so intriguing, we first need to talk about how we detect these interstellar visitors, how we separate them from the millions of objects that belong to our own solar system. It's a process that requires patience, precision, and a deep understanding of the dance of celestial mechanics. Picture, if you will, a vast network of telescopes scattered across the Earth, their electronic eyes constantly scanning the heavens. These aren't the romantic brass tubes of old astronomy, with lone observers peering through eyepieces on cold mountaintops. Modern astronomical surveys are automated systems, computers controlling precise motors that sweep telescopes across the sky in predetermined patterns, cameras capturing thousands of images each night, each image containing thousands of points of light. Most of these points of light are stars, distant suns that appear fixed in their positions night after night. But some are closer, objects within our own solar system, asteroids and comets that betray their presence through their motion against the stellar background. The software that processes these images is sophisticated, trained to recognize the characteristic movement of solar system objects, to track them from night to night, to calculate their orbits and predict their future positions. Every night, these surveys discover dozens of new asteroids, adding to a catalogue that now numbers in the millions. Most are ordinary chunks of rock and metal, leftovers from the formation of our solar system 4.6 billion years ago. They follow predictable paths, orbiting the Sun in the space between Mars and Jupiter, or in more distant regions beyond Neptune. Occasionally, one might have an orbit that brings it close to Earth, and these we watch more carefully, calculating and recalculating to ensure they pose no threat. But every once in a while, something different appears in the data, an object moving too fast or at the wrong angle, or on a path that doesn't quite make sense. The computers flag these anomalies for human attention, and astronomers around the world turn their instruments toward these cosmic mysteries, trying to understand what they're seeing. Most turn out to have simple explanations, unusual but not unprecedented orbits, or measurement errors that resolve with more observations. But sometimes, rarely, the mystery only deepens with further study. This is what happened with 3i Atlas. When it first appeared in the survey data, it was just another point of light, moving against the stars like countless others. But as astronomers gathered more observations, as they refined their calculations of its orbit, they began to realize they were looking at something extraordinary. The path this object was following couldn't be explained by an origin within our solar system. The mathematics were unambiguous. This object had come from somewhere else, from the vast spaces between the stars. Now, you might wonder how astronomers can be so certain about this. How can they look at a tiny point of light, barely visible even through powerful telescopes, and determine that it came from interstellar space? The answer lies in the beautiful precision of celestial mechanics, the mathematical laws that govern the motion of all objects in space. Every object bound to our Sun, every planet, asteroid and comet that belongs to our solar system, must follow certain rules, must move within certain constraints. Think of it like this. Imagine you're watching leaves floating down a river. Most of the leaves follow the current, moving at speeds and in directions determined by the flow of the water, but then you see one leaf moving differently, perhaps faster than the current could carry it, or at an angle that defies the flow. You would know immediately that something else was acting on that leaf, perhaps the wind, perhaps something underneath the water you can't see. This is similar to how astronomers identify interstellar objects. Objects that belong to our solar system are like those leaves following the river's current. They're bound by the sun's gravity, trapped in orbital paths that, while they can be quite eccentric, must still follow certain mathematical relationships. Their speed at any point in their orbit is determined by their distance from the sun and their orbital energy. They can't move too fast without escaping entirely, and if they're moving fast enough to escape, we can trace their paths backward and see that they originated from within the solar system, perhaps flung outward by a close encounter with a planet. But interstellar objects are different. They enter our solar system with speeds and trajectories that are impossible for objects that formed here. They're moving too fast, coming from directions that don't align with the plane where most solar system objects reside. When astronomers calculate their orbits, they find that these paths are hyperbolic, mathematical curves that extend to infinity rather than closing back on themselves. These objects are not bound to our Sun, they're just passing through, visitors from the vast interstellar ocean. The first confirmed interstellar object, Oumuamua, discovered in 2017, had shocked the astronomical community with its strange properties. It was moving too fast to have originated in our solar system, but that was just the beginning of its mysteries. As telescopes around the world focused on this visitor, they discovered that it was unlike anything we'd seen before. It was elongated, perhaps 10 times longer than it was wide, tumbling through space like a cosmic cigar. And strangest of all, it was accelerating in a way that couldn't be explained by gravity alone. Comets accelerate when they approach the Sun because the heat causes ice to sublimate, creating jets of gas that act like tiny rockets. But Oumuamua showed no signs of such outgassing, no visible coma or tail that should accompany such acceleration. Various theories were proposed, from unusual ice compositions to the possibility that it was a piece of cosmic dust bunny, a fractal aggregate of particles held together by weak forces. But none of these explanations were entirely satisfactory, and some scientists, notably Harvard astronomer Avi Loeb, suggested we should consider the possibility that Oumuamua was artificial. This suggestion was controversial to say the least. The scientific community is rightfully cautious about invoking aliens to explain mysterious phenomena. Throughout history, things we didn't understand were often attributed to gods or spirits or other supernatural causes, only to later be explained by natural processes we hadn't yet discovered. But Loeb argued that we shouldn't dismiss the possibility out of hand, that the unusual properties of Oumuamua were at least consistent with what we might expect from an artificial object, perhaps a light sail or a defunct probe. Whether or not you find this argument convincing, and we'll explore it more deeply as our night continues, it set the stage for how we would think about future interstellar visitors. When 3 Atlas was discovered 2 years later, astronomers were ready. They knew what to look for, what questions to ask, what observations to prioritize, and what they found was, in some ways, even more puzzling than Oumuamua. But before we delve into the specific mysteries of 3I Atlas, let's take a moment to appreciate the sheer improbability of detecting these objects at all. Space, as Douglas Adams famously wrote, is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. The volume of space within our solar system where we might detect an object like 3I Atlas is infinitesimally small compared to the volume of interstellar space it had to traverse to get here. The odds of such an object passing close enough to Earth for us to see it, during the brief window of human history when we have telescopes capable of detecting it, are astronomically small, and yet we've now detected at least 2 such objects in just a few years. This suggests one of 2 things. Either we've been extraordinarily lucky, winning a cosmic lottery twice in quick succession, or these objects are far more common than we previously thought. If it's the latter, if interstellar space is filled with such objects, passing through our solar system regularly, then where do they all come from? Natural processes can certainly fling objects out of planetary systems, but the numbers might suggest something more. Consider this. If every star system in our galaxy has ejected debris into interstellar space, and if this debris is distributed relatively evenly, then we can calculate roughly how many such objects should be passing through our solar system at any given time. The numbers are impressive, perhaps thousands of objects larger than Oumuamua within the orbit of Neptune right now. Most are too faint for us to detect with current technology, but they're there, silent travelers carrying information about distant star systems. But what if some of these objects aren't natural debris? What if some are probes, sent out by civilizations engaged in their own searches for life and intelligence? The numbers become even more intriguing when you consider that a single civilization, given enough time, could launch millions or even billions of probes. These wouldn't need to be large or sophisticated by our standards. They could be small, simple, designed to survive the long journey and perform basic observations when they encounter a star system. This strategy, sometimes called a Bracewell probe, after the scientist who first proposed it, has several advantages over trying to communicate via radio or other electromagnetic signals. Probes can wait indefinitely for the right conditions. They can gather detailed information about the systems they visit, and they can potentially serve as a form of communication that doesn't require both civilizations to exist at the same time. A probe launched millions of years ago by a long-dead civilization could still deliver its message to us today. As you drift deeper into relaxation, perhaps you can imagine these patient messengers scattered throughout the galaxy like seeds on the wind. Each one carries within it the hopes and dreams of its creators, their desire to know that they are not alone, their wish to share their existence with others. Even if the civilization that launched them is long gone, turned to dust by the inexorable march of time, their probes continue on, fulfilling their mission across the eons. The beauty of this idea is that it doesn't require any technology beyond what we can imagine developing ourselves in the coming centuries or millennia. We don't need faster-than-light travel or exotic physics. We just need patience, the kind of patience that comes from thinking not in terms of individual lives or even civilizations, but in terms of the deep time of the cosmos. And perhaps that's the most profound shift in perspective that contemplating these possibilities offers us. The recognition that our urgent human timescales are just one way of experiencing the universe. Now, let's return our attention to that quiet mountaintop observatory where 3I Atlas was first detected. It was June 2019, and the Asteroid Terrestrial Impact Last Alert System, ATLAS, was doing what it always does, scanning the sky for potentially hazardous asteroids. ATLAS consists of 4 telescopes, 2 in Hawaii, 1 in South Africa, and 1 in Chile, working together to survey the entire visible sky multiple times each night. The system is designed to provide warning of asteroids that might impact Earth, giving us perhaps weeks of notice for larger objects. On this particular night, the automated systems flagged an object for review. It was faint, just a few pixels of light against the dark background, but it was moving. The software calculated a preliminary orbit based on the observations, and something wasn't quite right. The object was moving too fast, and its path suggested it wasn't bound to the Sun. But these initial calculations are often uncertain based on limited data, so the discovery was noted and added to the list of objects requiring follow-up observations. Over the following nights and weeks, telescopes around the world turned toward this new object, gathering more data, refining the orbital calculations. Each new observation added another piece to the puzzle, constraining the possible paths the object could be following, and with each refinement, it became clearer that this was indeed another interstellar visitor, the third confirmed object from beyond our solar system. But there was something different about 3I Atlas, something that set it apart from its predecessors. While Oumuamua had been discovered on its way out of the solar system, already past its closest approach to the Sun and heading back to interstellar space, 3I Atlas was caught on its way in. This gave astronomers a precious opportunity to observe an interstellar object as it interacted with the inner solar system, to watch for changes in its behavior as it approached the Sun. The trajectory of 3I Atlas was fascinating in its own right. It approached our solar system from high above the ecliptic plane, the imaginary disk in which most planets orbit. This is typical for interstellar objects. They can come from any direction, not constrained to the plane where most solar system objects reside. As it fell toward the Sun, accelerated by our star's gravity, it would pass within Mercury's orbit, experiencing temperatures hot enough to vaporize many common ices. This close approach to the Sun, called perihelion, would be a crucial test. If 3 Atlas was a comet, a dirty snowball of ice and rock like many objects from the outer reaches of our own solar system, The sun's heat should cause it to develop a coma and tail. The ices would sublimate, creating a cloud of gas and dust around the nucleus, and the solar wind would blow this material into the characteristic tail that makes comets such spectacular sights in our night sky. But as 3I Atlas approached perihelion, astronomers watching closely saw something unexpected. Or rather, they didn't see what they expected. The object remained point-like in even the most powerful telescopes, showing no signs of the fuzzy coma that should surround an active comet. There was no tail streaming behind it, no jets of gas erupting from its surface. By all appearances, 3I Atlas looked like an inert rock, an asteroid rather than a comet. This was puzzling because most objects that come from the outer regions of star systems, whether our own or others, should contain significant amounts of ice. In the cold depths of space where these objects form, water, methane, ammonia and other volatiles freeze solid, becoming incorporated into the growing planetesimals. When these objects approach a star, the ices should sublimate, creating the activity we associate with comets. The fact that 3I Atlas showed no such activity suggested either that it had already lost all its volatile materials or that it never had them to begin with. But then the observations took another strange turn. Despite showing no visible signs of outgassing, no coma or tail that would indicate material streaming off its surface, 3I Atlas began to deviate from the path predicted by gravity alone. It was subtle at first, barely detectable, but as more observations accumulated, it became undeniable. The object was accelerating in a way that couldn't be explained by the gravitational forces of the sun and planets. This non-gravitational acceleration was eerily similar to what had been observed with Oumuamua. In that case, various theories had been proposed to explain the anomaly. Perhaps it was outgassing that was simply too faint for us to detect. Perhaps it was the pressure of sunlight itself, pushing on an object with an unusually large surface area relative to its mass. Perhaps it was something else entirely, something we hadn't thought of yet. With 3I Atlas, astronomers had a chance to test these theories with better data. The object was discovered earlier in its passage through the solar system, giving more time for observations. More advanced telescopes and techniques were brought to bear, searching for any sign of the mechanism causing the acceleration. Spectroscopic observations looked for the chemical signatures of different gases. Infrared telescopes searched for the heat signature of sublimating ices. Radio telescopes listened for any artificial signals, but the more data that was gathered, the deeper the mystery became. The acceleration didn't match what would be expected from any known type of outgassing. The object's brightness variation suggested it was rotating, but the pattern was complex, indicating an irregular shape or perhaps variations in surface reflectivity. And most intriguingly, the spectrum of light reflected from its surface didn't match any known type of asteroid or comet. It's important to pause here and acknowledge the careful, methodical work of the astronomers studying 3I Atlas. Science at its best is a process of systematic observation, hypothesis testing, and peer review. Every claim about the object's unusual properties had to be verified by multiple independent observations. Every possible source of error had to be considered and ruled out. This is slow, sometimes frustrating work, but it's the only way to build reliable knowledge about the universe. As you lie there in the darkness, perhaps feeling yourself sinking deeper into relaxation, consider the patience required for this kind of science. Astronomers might wait weeks for their turn on a major telescope, only to have clouds roll in at the crucial moment. They might spend months analyzing data, checking and rechecking their calculations, only to find that a subtle instrumental effect has contaminated their results. And yet they persist, driven by curiosity and the hope of understanding something new about the cosmos. This patience, this careful attention to detail, is what makes the anomalies of 3I Atlas so significant. These aren't wild claims based on blurry photos or ambiguous data. They're the result of rigorous observation and analysis by some of the world's leading astronomers. When these scientists say that 3I Atlas is behaving in ways we don't understand, it's not because they haven't looked hard enough for conventional explanations. It's because the conventional explanations don't fit the data. So what are we to make of this? How do we interpret an object that looks like an asteroid but accelerates like a comet, that comes from interstellar space but doesn't match any known type of celestial body? The conservative approach, the one favoured by most astronomers, is to assume there's a natural explanation we haven't thought of yet. Perhaps there's a type of ice we haven't considered, one that sublimates without producing visible gas. Perhaps there's a mechanism for non-gravitational acceleration that doesn't involve outgassing at all. But there's another possibility, one that we should at least consider, even if we don't embrace it fully. What if 3I Atlas is exactly what it appears to be? An object that doesn't fit our categories because it wasn't formed by natural processes? What if its strange properties are the result of design rather than chance, intention rather than accident? This doesn't mean we should immediately jump to the conclusion that it's an alien spacecraft, but perhaps we should keep an open mind about what we might be seeing. The history of science is full of discoveries that were initially dismissed because they didn't fit existing paradigms. Continental drift was considered absurd until plate tectonics provided a mechanism. The idea that rocks could fall from the sky was rejected until meteorites were properly understood. Sometimes the universe presents us with phenomena that require us to expand our conceptual frameworks, to consider possibilities we hadn't previously entertained. As we continue to watch 3I Atlas recede into the darkness, heading back to the interstellar void from which it came, we're left with more questions than answers, but perhaps that's as it should be. The universe is under no obligation to reveal its secrets on our schedule or in ways we find convenient. Sometimes the most profound discoveries come not from finding answers, but from finding better questions. The night is still young, and our journey through these cosmic mysteries has only just begun. As 3I Atlas continues on its path, carrying its secrets with it, we turn our attention to the broader implications of what we've observed. What does it mean for an object to follow an unnatural path through space? How do we distinguish between the merely unusual and the potentially artificial? And what might be the intentions of those who could have sent such an object our way? These are the questions that will guide us through the next phase of our contemplation, as we explore not just the physical properties of 3I Atlas, but the conceptual frameworks we use to understand objects like it. The boundary between natural and artificial, between coincidence and intention, becomes surprisingly blurry when we look closely enough. And in that blurry boundary, in that space of uncertainty, we might find new ways of thinking about our place in the cosmos. The story of 3I Atlas is far from over. Even as it fades from the view of our telescopes, its influence on our thinking continues to grow. Each new analysis of the data reveals subtle details we hadn't noticed before. Each theoretical paper exploring possible explanations opens up new avenues of investigation. And each night, astronomers continue to scan the skies, knowing that the next interstellar visitor could appear at any moment, bringing with it new mysteries to ponder. Consider for a moment the vast network of instruments and intellects focused on understanding these cosmic wanderers. In observatories scattered across every continent, astronomers are gathering data, sharing observations, debating interpretations. In universities and research institutes, theorists are developing models, running simulations, testing hypotheses. In space agencies around the world, engineers are designing new missions, new ways to study these objects when they appear. This global collaboration, this collective effort to understand, is perhaps humanity at its best. United in curiosity rather than divided by borders. And yet, despite all our instruments and intellect, 3I Atlas remains enigmatic. It refuses to fit neatly into our categories, to behave according to our expectations. In this refusal, in this stubborn mystery, there's something almost playful, as if the universe is reminding us that we still have much to learn, that our understanding is still incomplete. And perhaps that's the most valuable gift these interstellar visitors bring us. Not answers, but humility. Not certainty, but wonder. as we prepare to delve deeper into the specific anomalies of 3i Atlas's trajectory, let's carry with us this sense of open-minded inquiry. Let's be willing to follow the data wherever it leads, even if it takes us to unexpected places. Let's remember that the universe is far stranger and more wonderful than we can imagine, and that sometimes the most profound truths come disguised as mysteries. The path of 3i Atlas through our solar system tells a story, written in the language of celestial mechanics. To read this story, we need to understand not just where the object went, but how it moved, what forces acted upon it, and how it responded to those forces. Every deviation from the expected path is a clue, a hint about the object's nature and possibly its origin. And as we'll see, the path of 3i Atlas is full of such deviations, each one adding another layer to the mystery. In the conventional understanding of celestial mechanics, objects moving through space follow predictable paths determined by gravity. Newton's laws of motion and universal gravitation, refined by Einstein's general relativity, give us precise mathematical tools for calculating these paths. We can predict the positions of planets centuries in advance, guide spacecraft to distant worlds with pinpoint accuracy, and track the orbits of thousands of asteroids and comets. This predictability is one of the great triumphs of physics, evidence of the underlying order in what might otherwise seem like chaos. But 3i Atlas didn't follow the rules, or at least not the rules as we understand them. Its path through the solar system showed deviations that couldn't be explained by the gravitational pull of the sun and planets alone. These deviations were small, measured in kilometers over distances of millions of kilometers, but they were consistent and cumulative. Something was pushing on 3i Atlas, accelerating it in ways that gravity couldn't account for. The first instinct of astronomers was to look for natural explanations. Cometary outgassing was the obvious candidate. When ices sublimate from a comet's surface, they create jets of gas that can act like tiny rockets, pushing the comet in unexpected directions. This is a well-understood phenomenon, observed in countless comets over the centuries, but as we've already discussed, 3i Atlas showed no visible signs of such outgassing, no coma or tail that should accompany it. Another possibility was radiation pressure, the gentle push of sunlight itself. Photons, particles of light, carry momentum, and when they strike an object, they transfer some of that momentum, creating a tiny force. For most objects, this force is negligible compared to gravity, but for objects with a large surface area and low mass, like a solar sail, it can be significant. Could 3i Atlas be such an object, perhaps a thin sheet of material tumbling through space? This idea, while intriguing, faced its own challenges. For radiation pressure to produce the observed acceleration, 3i Atlas would need to be extraordinarily thin, perhaps less than a millimeter thick, yet hundreds of meters across. Such an object would be unlike anything we've observed in our own solar system, where even the smallest particles tend to be roughly spherical or irregular chunks rather than flat sheets. Moreover, the way radiation pressure affects an object depends on its orientation relative to the sun, and 3i Atlas's tumbling motion would have averaged out much of this effect. As days turn to weeks and weeks to months, astronomers continue to track 3i Atlas, gathering more data, refining their models. They use some of the most powerful telescopes on Earth and in space, including the Hubble Space Telescope and the Very Large Telescope in Chile. Each observation added another data point, another constraint on the possible explanations for the object's behavior. One of the most intriguing aspects of 3i Atlas's motion was its consistency. The non-gravitational acceleration wasn't random or chaotic. It followed a pattern, changing in a predictable way as the object's distance from the sun changed. This suggested that whatever was causing the acceleration was related to solar heating or solar radiation, but in a way we didn't fully understand. Some theorists proposed exotic forms of ice that might sublimate without producing visible gas. Perhaps 3i Atlas was composed of hydrogen ice, which would be nearly invisible to our telescopes when it evaporated, or perhaps it was made of nitrogen ice, like some objects in our own outer solar system, but these explanations had their own problems. Hydrogen ice should have completely evaporated long before 3I Atlas reached our solar system, and nitrogen ice should still produce some detectable emissions. As the mystery deepened, some scientists began to consider more unconventional possibilities. What if 3I Atlas wasn't accelerating due to any force at all, but rather our understanding of gravity at these scales was incomplete? What if there were subtle effects, perhaps related to dark matter or modified theories of gravity, that only became apparent for objects with certain properties? These ideas were speculative, to be sure, but the failure of conventional explanations forced astronomers to think outside the box. And then there was the possibility that dare not speak its name in most scientific circles, the idea that 3I Atlas might be artificial. This wasn't just wild speculation. There were specific aspects of its behavior that were consistent with what we might expect from an artificial object. The consistency of its acceleration, the lack of visible outgassing, the unusual spectral properties, all of these could be explained if 3I Atlas was a manufactured object rather than a natural one. But what kind of artificial object would behave this way? One possibility was a light sail, a thin membrane designed to be pushed by stellar radiation. Such sails have been proposed for interstellar travel, as they could potentially reach high speeds without carrying fuel. If an alien civilization had launched light sails to explore the galaxy, some might eventually pass through our solar system, appearing to us as mysterious accelerating objects. Another possibility was that 3I Atlas was a probe that was actively maneuvering, using some form of propulsion we couldn't detect. Perhaps it had ion drives or other low-thrust engines that were adjusting its trajectory for reasons we couldn't fathom. This would explain the consistent but mysterious acceleration, though it raised the question of why such a probe would reveal itself through its motion while remaining otherwise silent. Or perhaps, and this is where we enter the realm of pure speculation, 3I Atlas was something else entirely, an artifact whose purpose and nature were beyond our current understanding. Maybe it was a beacon, designed to attract attention through its anomalous behavior. Maybe it was a test, a way for an advanced civilization to gauge our technological and intellectual development. Or maybe it was something so alien that we lack the conceptual framework to even understand its purpose. As you contemplate these possibilities, feeling yourself sink deeper into a state of peaceful wonder, consider what it means to encounter something truly alien. Not just foreign or unfamiliar, but fundamentally different from anything in our experience. How would we recognize such a thing? How would we study it? How would we even know what questions to ask? The challenge of understanding 3I Atlas is not just a scientific one, it's a philosophical and conceptual one. It forces us to confront the limits of our knowledge, the assumptions built into our ways of thinking. We tend to interpret the unknown in terms of the known, to see patterns that fit our preconceptions. But what if 3I Atlas represents something genuinely new? Something that requires us to develop new concepts, new ways of thinking. This is not the first time astronomy has faced such a challenge. When pulsars were first discovered, their regular radio pulses were so unlike anything astronomers had seen that they briefly considered the possibility that they were artificial signals, dubbing them LGM for Little Green Men. Of course, pulsars turned out to be natural, the result of rapidly rotating neutron stars, but the discovery required astronomers to expand their understanding of what was possible in nature. Similarly, when dark matter and dark energy were discovered, they challenged our most fundamental theories about the universe. Here were phenomena that couldn't be explained by any known form of matter or energy, forcing physicists to postulate entirely new components of reality. Even today, decades after their discovery, we still don't know what dark matter and dark energy actually are, only that they must exist to explain our observations. Could 3I Atlas represent a similar paradigm shift? Could it be the first evidence of something that will fundamentally change our understanding of the universe? Or is it simply an unusual but ultimately natural object, one that will eventually be explained by some clever theory or previously overlooked mechanism? We don't know, and that uncertainty, that open question, is both frustrating and exhilarating. As 3 Atlas continued its journey through the inner solar system, approaching its closest point to the Sun, astronomers prepared for what they hoped would be the most revealing observations yet. The intense solar heating at perihelion should trigger any volatile materials to become active, providing the best chance to detect outgassing if it was occurring. Special observing campaigns were organized, with multiple telescopes coordinating to provide continuous coverage. The days around perihelion were tense with anticipation. Data streamed in from observatories around the world, each image scrutinized for any sign of activity. Spectroscopes searched for the telltale signatures of different gases. Infrared detectors looked for thermal emissions. Radio telescopes listened for any signals, natural or otherwise. But as the data was analyzed, the mystery only deepened. 3I Atlas passed through perihelion as enigmatically as it had approached, showing no obvious signs of the activity that should accompany a comet's close encounter with the Sun. And yet, the non-gravitational acceleration continued, even intensified, as if whatever was causing it was responding to the increased solar radiation. The pattern was maddeningly consistent with some form of outgassing or radiation pressure, but without any of the observable effects such mechanisms should produce. It was as if 3I Atlas was following the script of a comet while refusing to play the part, exhibiting the effects without the causes. Some astronomers began to speak of 3I Atlas as a dark comet, an object that behaves like a comet but doesn't look like one. This term, while evocative, was more a description of our ignorance than an explanation. It acknowledged that something was pushing on the object, something related to its interaction with sunlight. But we couldn't see what that something was. It was a label for a mystery, not a solution to it. As 3 Atlas began to recede from the Sun, heading back toward interstellar space, there was a sense that an opportunity was slipping away. Each day the object grew fainter in our telescopes, more difficult to observe. The window for studying this interstellar visitor was closing, and we still didn't understand what we were looking at. Proposals were hastily drawn up for space missions that might intercept future interstellar objects. But for 3I Atlas, we could only watch as it departed, taking its secrets with it. But even as 3I Atlas faded from view, its impact on our thinking continued to grow. The object had challenged our assumptions, forced us to confront the limits of our understanding. It had shown us that the universe still holds surprises, that there are phenomena we don't yet understand, possibly things we haven't even imagined. And in that reminder of our ignorance, there was something profoundly humbling and inspiring. The trajectory of 3I Atlas, that unnatural path through our solar system, had become more than just a scientific puzzle. It had become a mirror, reflecting our own assumptions and limitations. In trying to understand this cosmic visitor, we were forced to examine our own ways of thinking, our own conceptual frameworks. And in that examination, we might have learned as much about ourselves as about the object we were studying. As we move forward in our contemplation, carrying with us the mystery of 3I Atlas's impossible acceleration, we prepare to explore another dimension of this cosmic puzzle. The light reflected from this enigmatic object carries its own secrets, encoded in wavelengths and intensities that tell a story of composition and structure. In the subtle variations of brightness and colour, in the spectral lines that reveal chemical signatures, we might find clues to the true nature of our interstellar visitor. But first, let yourself drift for a moment in the profound quiet of space, where 3 Atlas continues its journey, neither hurrying nor delaying, following its mysterious path through the cosmos. Out there, in the cold darkness between worlds, it carries whatever secrets it holds, patient and eternal, a riddle written in the language of motion and light, waiting for someone, somewhere, somewhen, to understand its message. The story of how we decode the light from distant objects is itself a kind of poetry, a testament to human ingenuity and our deep desire to understand the cosmos. Every photon that reaches our telescopes from 3i Atlas has travelled millions of kilometres, carrying information about the object that reflected or emitted it. These photons are messengers, bearing news from a cosmic frontier we cannot physically reach, at least not yet. When light strikes an object, some wavelengths are absorbed while others are reflected, creating a unique spectral signature that can reveal the object's composition. It's like a fingerprint made of light, distinctive and revealing. Different materials absorb and reflect different wavelengths, allowing astronomers to identify substances from across the vast distances of space. This technique, called spectroscopy, has revealed the composition of stars, planets, and galaxies billions of light-years away. For 3i Atlas, spectroscopy offered the promise of understanding what this mysterious object was made of, potentially revealing whether it was a rocky asteroid, an icy comet, or something else entirely. Teams of astronomers around the world pointed their spectroscopes at the faint point of light, gathering photons and spreading them out into their component wavelengths, searching for the telltale patterns that would reveal 3i Atlas's composition. But like everything else about this object, the spectroscopic data refused to fit neatly into existing categories. The spectrum of 3i Atlas was peculiar, showing features that didn't match any known class of asteroid or comet. There were hints of organic compounds, suggestions of unusual minerals, patterns that seemed to shift depending on the object's rotation. It was as if 3i Atlas was made of materials we recognized, but combined in ways we'd never seen before. One of the most intriguing aspects of the spectroscopic data was its variability. As 3i Atlas tumbled through space, different faces of the object were presented to our telescopes, and the spectrum changed accordingly. This suggested that the object's surface was not uniform, that different regions had different compositions or textures. Such heterogeneity is not unusual for asteroids and comets, which can have complex geological histories, but the specific patterns observed for 3i Atlas were unlike anything in our catalogues. Some regions of the object seemed to be highly reflective, almost mirror-like, while others were dark, absorbing most of the light that struck them. This created a complex pattern of brightness variations as the object rotated, a pattern that proved difficult to model. Astronomers tried to reconstruct the shape and surface properties of 3i Atlas from these brightness variations, but the solutions were non-unique. Multiple different shapes and surface configurations could produce the observed light curve. The colour of 3i Atlas was another puzzle. In astronomy, colour doesn't just mean what we see with our eyes, but the relative brightness of an object at different wavelengths across the electromagnetic spectrum. Most asteroids and comets fall into distinct colour classes that correlate with their composition and origin. But 3 Atlas didn't fit cleanly into any of these classes. Its colour was somewhere between the red of many outer solar system objects and the grey of inner solar system asteroids, with subtle variations that changed over time. These colour variations could have several explanations. Perhaps 3i Atlas had a patchy surface, with different regions having different compositions. Perhaps it was covered with a thin layer of dust or other material that was being gradually removed by solar radiation. Or perhaps, and this is where things get particularly interesting, the surface was being actively modified by processes we couldn't directly observe. One hypothesis that gained some traction was that 3i Atlas might be covered with a thin layer of organic polymers, complex carbon-based molecules that had been processed by eons of exposure to cosmic rays. Such materials, sometimes called tholins, are thought to be common on objects in the outer solar system and could potentially give 3i Atlas its unusual spectral properties. But the specific spectral features didn't quite match laboratory measurements of known tholins, suggesting that if this explanation was correct, the materials on 3i Atlas were somehow different from what we'd encountered before. The infrared observations of 3i Atlas were particularly revealing, or perhaps it would be more accurate to say they were particularly puzzling. In the infrared, we can detect thermal emission from objects, the heat they radiate based on their temperature. For a simple, inert object like an asteroid, The temperature should be determined primarily by its distance from the Sun and its rotational period. The sunlit side heats up, the dark side cools down, and the infrared emission varies accordingly. But 3i Atlas didn't behave like a simple, inert object. Its infrared emission showed anomalies that suggested either unusual thermal properties or internal heat sources. The object seemed to retain heat longer than expected, and there were occasional spikes in infrared emission that couldn't be explained by solar heating alone. These thermal anomalies added another layer to the mystery, suggesting that 3i Atlas might be more than just a passive chunk of rock or ice. One particularly intriguing observation came from the Spitzer Space Telescope, one of our most sensitive infrared observatories. Spitzer detected what appeared to be a faint infrared excess from 3i Atlas, emission at wavelengths that couldn't be explained by simple thermal radiation. This excess was subtle, right at the edge of detectability, but if real, it suggested that something unusual was happening on or within the object. The infrared excess could have several explanations, each more intriguing than the last. Perhaps 3i Atlas was surrounded by a cloud of dust, too thin to see invisible light but warm enough to glow in the infrared. Perhaps there were chemical reactions occurring on its surface, triggered by solar radiation and producing heat. Or perhaps, and this is where we venture into truly speculative territory, the object contained some form of technology that was producing waste heat, the thermal signature of machinery we couldn't otherwise detect. As you lie there in the gentle darkness, perhaps feeling your breathing slow and deepen, consider what it means to observe something across such vast distances using only the light it reflects or emits. We're like detectives trying to solve a mystery using only shadows and echoes, piecing together a picture from the faintest of clues. Every photon that reaches us from 3i Atlas has to travel millions of kilometers through the vacuum of space, surviving its journey to bring us a tiny fragment of information about this enigmatic visitor. The polarization of light from 3i Atlas provided yet another piece of the puzzle. When light reflects off a surface, it can become polarized, with the light waves aligned in a particular direction. The degree and angle of polarization depend on the surface properties of the reflecting object, its composition, texture, and the angle at which we're viewing it. For 3i Atlas, the polarization measurements were, unsurprisingly, unusual. The object showed strong polarization at certain angles, suggesting a very smooth or possibly metallic surface, but at other angles the polarization was weak or absent, indicating rough or powdery regions. This dichotomy was difficult to reconcile with any single type of object we knew. It was as if 3i Atlas was part mirror, part rock, a combination that doesn't occur naturally in any asteroids or comets we've studied. Some astronomers suggested that 3i Atlas might be covered with a thin layer of metal, perhaps iron or nickel that had been deposited on its surface through some unknown process. In the extreme environment of interstellar space, with its cosmic rays and magnetic fields, perhaps unusual chemical processes could create such metallic coatings. But this was speculation built on speculation, a house of cards of hypotheses trying to explain observations that defied conventional understanding. The search for specific molecular signatures in the spectrum of 3i Atlas was particularly intensive. Astronomers looked for the spectral lines of water, methane, ammonia, and other volatiles that should be present if the object was a comet. They searched for the signatures of silicates and metals that would indicate an asteroidal composition. They even looked for more exotic materials, things that might not occur naturally but could be present if the object was artificial. One team claimed to have detected a faint signature that might be consistent with complex organic molecules, possibly even amino acids or their precursors. If confirmed, this would be extraordinary, as it would suggest that 3i Atlas carried the building blocks of life, or at least complex chemistry that could lead to life. But the detection was marginal, and other teams couldn't reproduce it with their data. Like so many aspects of 3i Atlas, it remained tantalizingly uncertain. The variability of 3i Atlas's brightness over time, what astronomers call its light curve, was perhaps the most extensively studied aspect of the object. By carefully measuring how the brightness changed as the object rotated, astronomers could infer its shape, or at least constrain the possible shapes it might have. But 3 Atlas's light curve was complex, showing multiple periodicities that suggested either a very irregular shape or a combination of rotation and precession. The primary rotation period appeared to be about 7.3 hours, fairly typical for an object of its estimated size. But there were also longer-term variations, cycles that repeated over days or weeks. These could indicate that 3 Atlas was not just spinning but tumbling, its axis of rotation itself rotating through space. Such complex rotation is not unusual for asteroids, especially those that have been disturbed by collisions or close encounters with planets. But the specific pattern of 3I Atlas's tumbling was unique, unlike anything in our databases of asteroid light curves. Some researchers attempted to use machine learning algorithms to find the best fit model for 3I Atlas's shape based on its light curve. They generated millions of possible shapes, simulated how each would appear as it tumbled through space, and compared the results to the observations. The models that best matched the data suggested that 3I Atlas was highly elongated, perhaps 3 or 4 times longer than it was wide, with an irregular, possibly faceted surface. But even the best models couldn't fully explain all the features of the light curve. There were sudden changes in brightness that didn't fit any simple geometric shape. Moments when the object seemed to flash or glint as if a mirror-like surface had caught the sunlight just right. These glints were rare and unpredictable, adding another element of mystery to an already puzzling object. As 3 Atlas continued its journey through the solar system, astronomers organized coordinated observation campaigns, with telescopes around the world and in space working together to provide continuous coverage. The goal was to catch any transient phenomena, any brief events that might reveal something about the object's nature. These campaigns required precise coordination, with observers in different time zones handing off to each other as the Earth rotated, ensuring that 3I Atlas was never out of sight for long. During one of these campaigns, something extraordinary happened. For a brief period lasting only about 30 minutes, 3I Atlas appeared to brighten significantly, becoming almost twice as bright as normal. The brightening was smooth, not the sharp flash you might expect from a rotating mirror, but a gradual increase and then decrease, as if something had activated and then deactivated. The event was observed by multiple telescopes, ruling out instrumental error, but it never repeated, at least not during our observations. What could cause such a brightening? One possibility was an outburst of gas and dust, similar to what comets sometimes experience. But there was no spectroscopic evidence of gas, no change in the object's appearance other than the brightness. Another possibility was that we'd witnessed a phase change on the object's surface, perhaps ice suddenly crystallizing or some other material undergoing a transition triggered by temperature or solar radiation. But the smoothness and duration of the event didn't quite fit these explanations. The most intriguing possibility, though we must be careful not to jump to conclusions, was that the brightening was caused by some form of technology, perhaps solar panels deploying to catch more sunlight, or a beacon activating to signal its presence. These ideas might sound like science fiction, but when faced with observations that don't fit natural explanations, we must at least consider artificial ones, even if we don't fully embrace them. The radio observations of 3I Atlas deserve special attention, as they represented our most direct search for signs of artificial origin. If 3I Atlas was some form of alien probe, it might be transmitting radio signals, either as communication, navigation beacons, or telemetry. Radio telescopes around the world, including some of the most sensitive instruments ever built, were pointed at the object, listening across a wide range of frequencies for any sign of artificial signals. The search was comprehensive, covering not just the obvious frequencies like the hydrogen line at 1420 MHz, which some have suggested would be a natural choice for interstellar communication, but the entire radio spectrum accessible from Earth. Sophisticated signal processing algorithms looked for patterns in the noise, anything that stood out from the natural radio emissions of space. The data was even analysed by SETI researchers, experts in the search for extraterrestrial intelligence, who brought their specialised techniques to bear on the problem. But the radio spectrum of 3I Atlas was silent, or more accurately, it was no different from the background noise of space. There were no narrow band signals, no modulated carriers, no digital patterns that would indicate artificial transmission. If 3I Atlas was artificial, it wasn't broadcasting, at least not in any way we could detect. This silence was itself informative, ruling out certain scenarios while leaving others open. Of course, the absence of radio signals doesn't prove that 3I Atlas is natural. An alien probe might maintain radio silence for any number of reasons. Perhaps it's designed to observe without announcing its presence. Perhaps it communicates using technologies we haven't discovered yet. Tight beam lasers or neutrino transmissions or something even more exotic. Or perhaps it's simply defunct. A dead probe drifting through space, its transmitters long since failed. The optical observations continued to reveal new details as 3I Atlas approached and then passed its closest point to Earth. At this point, it was still millions of kilometers away, far beyond the reach of our spacecraft, but close enough for our best telescopes to resolve some surface features. The images were blurry, pixelated, pushed to the very limits of what our technology could achieve, but they showed that 3I Atlas was indeed elongated, with what appeared to be variations in surface brightness along its length. One particularly intriguing image, captured by the Hubble Space Telescope during a brief window of exceptional viewing conditions, seemed to show a linear feature running along part of 3I Atlas's surface. It could have been a ridge, a crack, or perhaps just an artifact of the image processing. But to some eyes, it looked almost like a seam, as if the object was constructed from separate pieces joined together. The image was endlessly analysed, enhanced, and debated, but no consensus was reached about what it actually showed. As 3 Atlas began to recede from the inner solar system, climbing back up the sun's gravity well toward interstellar space, there was a palpable sense of urgency in the astronomical community. Every day the object grew fainter, more difficult to observe. The window of opportunity was closing, and there was still so much we didn't understand. Proposals for rapid response missions that could intercept future interstellar objects were accelerated, but for 3I Atlas, all we could do was watch and gather what data we could before it disappeared forever. The last reliable observations of 3I Atlas came from the largest telescopes on Earth, straining to detect the faint point of light against the background stars. By this time, the object was so distant that even determining its position accurately was challenging. But the astronomers persisted, squeezing every last photon of information from their instruments, unwilling to let go of this cosmic mystery without a fight. In those final observations, there was one last surprise. The spectrum of 3I Atlas seemed to change, showing features that hadn't been present before. It was as if the object's surface composition had altered, or perhaps a different face was being presented to us as it tumbled. Some speculated that the change was due to the object moving into a different thermal regime as it left the inner solar system, triggering phase changes in surface materials. Others wondered if we were seeing evidence of active processes, perhaps the object reconfiguring itself for the long journey through interstellar space. And then, finally, 3 Atlas faded beyond our ability to detect it. The last images showed nothing but the background stars, no trace of our mysterious visitor. It had come from the void and returned to it, leaving us with more questions than answers, more mysteries than revelations. But in its wake, it left something invaluable, an expanded sense of possibility, a reminder that the universe still holds surprises, and perhaps, just perhaps, a clue to one of the greatest questions of all. Are we alone? The story of 3I Atlas cannot be told without reference to its predecessor, the enigmatic Oumuamua, the first confirmed interstellar object to pass through our solar system. When Oumuamua was discovered in October 2017, it sent shockwaves through the astronomical community and captured the public imagination in a way few celestial objects ever have. Its very name, Hawaiian for scout or messenger from afar arriving first, seemed to carry a weight of cosmic significance, as if humanity had been waiting for just such a visitor without knowing it. Oumuamua was discovered by the Pan-STARRS telescope in Hawaii, appearing first as just another point of light moving against the background stars. But as astronomers calculated its orbit, they realized they were looking at something unprecedented in the history of astronomy, an object that had come from beyond our solar system, a piece of another star's planetary system, or perhaps something even stranger, passing through our cosmic neighborhood like a ship in the night. The initial observations of Oumuamua were startling. The object was moving at about 26 kilometers per second relative to the Sun, far too fast to be gravitationally bound to our star. Its trajectory showed that it had come from the direction of the constellation Lyra, though its actual origin was likely much more complex, involving millions or billions of years of travel through interstellar space. As telescopes around the world turned toward this cosmic visitor, the mysteries only deepened. Oumuamua's shape was perhaps its most striking characteristic. Based on its dramatic brightness variations as it tumbled through space, astronomers calculated that it was highly elongated, perhaps 10 times longer than it was wide. Some models suggested it might be cigar-shaped, others that it might be more like a pancake, flat and disc-like. Either way, it was unlike any asteroid or comet we'd observed in our own solar system, where most objects are roughly spherical or only modestly elongated. This unusual shape immediately raised questions. How could such an elongated object form naturally? In our solar system, objects tend to be rounded by their own gravity or by collisions with other objects. An object as elongated as Oumuamua seemed to defy these processes, suggesting either an unusual formation mechanism or perhaps, as some boldly suggested, an artificial origin. The idea that Oumuamua might be an alien artifact was first proposed almost jokingly, but as more anomalies accumulated, some scientists began to take it seriously. The acceleration anomaly was what really set Oumuamua apart and drew parallels with what we would later observe with 3I Atlas. As Oumuamua receded from the Sun, astronomers noticed that it wasn't following the path predicted by gravity alone. It was accelerating, pushed by some force other than the gravitational pull of the Sun and planets. The deviation was small but measurable, and it grew over time, becoming impossible to ignore or explain away as measurement error. For comets, such non-gravitational acceleration is common and well understood. As ices sublimate from their surfaces, the escaping gas acts like a jet, pushing the comet in the opposite direction. But Oumuamua showed no signs of cometary activity. There was no visible coma, no tail, no spectroscopic evidence of outgassing. It looked like an asteroid but behaved like a comet, a contradiction that puzzled astronomers and fueled speculation about its nature. Various theories were proposed to explain Oumuamua's acceleration. Perhaps it was outgassing, but with a type of ice that sublimated without producing visible gas. Hydrogen ice was one possibility, as molecular hydrogen would be nearly impossible to detect with our telescopes. But hydrogen ice should have completely sublimated long before Oumuamua reached our solar system, unless it had been somehow protected or replenished. Another possibility was that Oumuamua was composed of nitrogen ice, like the surface of Pluto, which might sublimate more subtly than water ice. But the theory that captured the most attention and controversy was proposed by Avi Loeb, the chair of Harvard's astronomy department. Loeb suggested that Oumuamua might be a light sail, a thin sheet of material designed to be pushed by stellar radiation. This would explain both its unusual shape and its anomalous acceleration. If Oumuamua was a light sail, it could be either a piece of alien technology, perhaps a defunct probe, or a fragment of some larger structure, or a naturally occurring but extremely unusual object. The light sail hypothesis was met with skepticism by most of the astronomical community. For Oumuamua to be accelerated by radiation pressure to the observed degree, it would need to be extraordinarily thin, perhaps less than a millimetre thick, yet hundreds of metres across. Such an object seemed unlikely to survive the journey through interstellar space, where it would be bombarded by cosmic rays and micrometeoroids. Moreover, there was no direct evidence that Oumuamua was particularly thin or flat. Its shape was inferred from brightness variations which could have other explanations. But Loeb persisted, arguing that we should at least consider the possibility that Oumuamua was artificial. He pointed out that humanity had already conceptualized and even built light sails, such as the Icaros spacecraft launched by Japan. If we could imagine using light sails for interstellar travel, why couldn't other civilizations have actually done it? The fact that Oumuamua's properties were consistent with a light sail, even if they might have other explanations, was worth taking seriously. The debate over Oumuamua's nature became a fascinating case study in how science deals with anomalous observations. On one side were those who insisted on natural explanations, arguing that invoking aliens was premature and unscientific. On the other were those who felt that dismissing the artificial hypothesis out of hand was equally unscientific, that we should follow the evidence wherever it led, even if it led to uncomfortable conclusions. The truth was that we simply didn't have enough data to definitively determine what Oumuamua was. As you drift deeper into contemplation, perhaps feeling the weight of your body sinking into your bed, consider the profound implications of Oumuamua's visit. Whether natural or artificial, it demonstrated that objects from other star systems could and did pass through our solar system. It showed us that the space between stars, which we once thought of as empty, might actually be populated with countless wandering objects, each carrying information about its origin and history. The discovery of Oumuamua also revealed how unprepared we were for such visitors. By the time we recognized what it was, Oumuamua was already on its way out of the solar system, moving too fast for any of our spacecraft to catch up. We had only a few weeks to observe it before it faded beyond the reach of our telescopes. If Oumuamua was artificial, if it was a probe sent by another civilization, we had missed our chance to study it in detail, to perhaps learn something profound about our place in the universe. This realization sparked a flurry of activity in the astronomical community. New surveys were proposed to detect interstellar objects earlier in their passages through the solar system. Mission concepts were developed for spacecraft that could be rapidly launched to intercept and study such objects. The European Space Agency's Comet Interceptor mission, already in development, was modified to be capable of studying an interstellar object if one was discovered in time. The astronomical community was determined not to be caught off guard again. When 3A Atlas was discovered 2 years after Oumuamua, astronomers were better prepared. The lessons learned from Oumuamua had been absorbed, the observation protocols refined, the theoretical frameworks expanded. But as we've seen, 3I Atlas brought its own mysteries, its own challenges to our understanding. In some ways, it was even more puzzling than Oumuamua, its properties even harder to explain with conventional theories. The parallels between Oumuamua and 3I Atlas were striking. Both showed non-gravitational acceleration without visible outgassing. Both had unusual spectral properties that didn't match typical asteroids or comets. Both seemed to defy easy categorization, existing in a liminal space between the natural and the possibly artificial. It was as if the universe was presenting us with a new class of objects, one that we didn't yet have the conceptual framework to understand. Some astronomers began to speak of dark comets, objects that behaved like comets but didn't look like them. Perhaps, they suggested, there was a population of such objects in interstellar space, formed under conditions different from those in our solar system, with properties we hadn't anticipated. This was a conservative interpretation, one that stayed within the bounds of natural phenomena, but it still required expanding our understanding of what was possible. Others went further, suggesting that the similarities between Oumuamua and 3I Atlas might indicate a common origin or purpose. If both were artificial, they might be part of a systematic survey of star systems by an alien civilization. Perhaps they were von Neumann probes. self-replicating spacecraft that could explore the entire galaxy given enough time. Or perhaps they were beacons designed to attract the attention of emerging technological civilizations like our own. The idea of directed panspermia also gained renewed attention. This hypothesis, first seriously proposed by Francis Crick and Leslie Orgel, suggests that life might be deliberately spread through the galaxy by intelligent civilizations. Could Oumuamua and Three-Eye Atlas be carrying microorganisms or the building blocks of life, either naturally or by design? The detection of possible organic compounds on both objects, though uncertain, lent some credence to this idea. But there was also a more subtle possibility, one that didn't require either object to be actively artificial. Perhaps Oumuamua and Three-Eye Atlas were natural objects that had been modified or marked in some way by an alien civilization. Just as we put plaques on our Pioneer and Voyager spacecraft, perhaps another civilization had marked certain interstellar objects as messages or memorials, knowing they would eventually be discovered by others. The philosophical implications of these possibilities were profound. If Oumuamua and Three-Eye Atlas were artificial, or even if they were natural but deliberately directed toward our solar system, it would mean that we were not alone, that other intelligences existed and were aware of us, or at least aware that stars like our sun might harbour life. It would be the most important discovery in human history, fundamentally changing our understanding of our place in the universe. But even if both objects were entirely natural, their existence was still revolutionary. They showed us that interstellar space was not empty, but populated with wandering objects, each a messenger from distant stars. They demonstrated that the solar system was not isolated but connected to the broader galaxy through these cosmic travelers, and they reminded us that the universe was full of phenomena we hadn't anticipated, mysteries we hadn't even known to look for. The comparison between Oumuamua and Three-Eye Atlas also highlighted how much we had learned in just 2 years. The observations of Three-Eye Atlas were more comprehensive, the analysis more sophisticated. We had better models for interstellar objects, better understanding of what to look for. But this increased knowledge also made the mysteries more apparent. The more we learned, the more we realized how much we didn't know. One of the most intriguing differences between the two objects was their trajectories through the solar system. Oumuamua had passed relatively close to the Sun within Mercury's orbit, but at a steep angle to the ecliptic plane. Three-Eye Atlas, on the other hand, had a more moderate trajectory basis, though still clearly hyperbolic. Some researchers wondered if these different paths might indicate different origins or purposes, if indeed the objects were artificial. The timing of the discoveries was also interesting. 2 confirmed interstellar objects in just 2 years, after centuries of astronomical observation without detecting any, suggested either that we had recently become capable of detecting something that had always been there, or that the rate of such visits was increasing. If the latter, why? Was it just coincidence, or was there something special about this particular time in Earth's history? Some speculated about a connection to our own technological development. Humanity had only been broadcasting radio signals for about a century, and strong radar signals for even less time. If an alien civilization had detected these signals and sent probes in response, they would be arriving about now. Given the light travel time to nearby stars and the slower travel time of physical probes. This was pure speculation, of course, but it was impossible not to wonder about the timing. The search for earlier interstellar objects in historical records became a minor industry. Astronomers combed through old observations, looking for objects with unusual orbits that might have been interstellar visitors, misidentified as comets or asteroids. A few candidates were found, objects with suspiciously hyperbolic orbits observed in the 19th or early 20th century, but the data was too poor to be certain. It seemed that Oumuamua really was the first confirmed interstellar object, at least in recorded history. But what about unrecorded history? Could interstellar objects have influenced Earth in the past, perhaps even playing a role in the development of life? Some researchers suggested that impacts from interstellar objects might have delivered organic compounds or even microorganisms to the early Earth. Others wondered if the unusual properties of certain meteorites might indicate an interstellar origin. These ideas were highly speculative, but they showed how the discovery of Oumuamua and Three-Eye Atlas had opened up entirely new avenues of thought. The cultural impact of these discoveries was also significant. Oumuamua, in particular, captured the public imagination in a way few astronomical discoveries do. It was featured in news stories, documentaries, and science fiction novels. It became a symbol of the unknown, the mysterious, the possibility that we were not alone. 3 Atlas, while less famous, added to this sense of cosmic mystery, reinforcing the idea that the universe was full of surprises. The scientific debate over these objects also played out in public, with prominent scientists taking different positions on their possible artificial nature. This was science in action, messy and uncertain, with smart people disagreeing about how to interpret ambiguous data. It was a reminder that science is not a collection of facts, but a process of inquiry, one that sometimes leads us into uncharted territory, where our usual assumptions and methods might not apply. As we reflect on the echoes between Oumuamua and Three-Eye Atlas, we see not just two anomalous objects, but a potential paradigm shift in our understanding of the solar system and our place in the galaxy. These visitors from the void had shown us that we are part of a larger cosmic community, connected to distant stars through these wandering messengers. Whether they were natural or artificial, they had expanded our horizons, challenged our assumptions, and reminded us of how much we still had to learn. The night continues to deepen around you, and perhaps you can feel yourself drifting like these cosmic wanderers, untethered from the familiar, exploring new realms of possibility. In this state of gentle contemplation, we prepare to consider an even more profound question. What if these objects were not just passing through, but were sent with purpose, carrying a message we have yet to decode? What if Three-Eye Atlas and Oumuamua were indeed silent messengers, waiting patiently for us to understand their significance? The concept of interstellar communication through physical artifacts rather than electromagnetic signals is not new to human thought. In fact, it predates our ability to send or receive radio signals by millennia. Ancient civilizations carved messages in stone, knowing that these would outlast papyrus or parchment. They built monuments that would endure for thousands of years, carrying information across vast spans of time. In a sense, the pyramids of Egypt and the megaliths of Stonehenge are messages from the past, artifacts that communicate across temporal rather than spatial distances. When we consider communication across interstellar distances, we face challenges that dwarf anything encountered in human history. The nearest star to our Sun, Proxima Centauri, is about 4.2 light-years away. A radio signal sent to a planet orbiting that star would take 4.2 years to arrive, and any response would take another 4.2 years to return. A conversation with even our nearest neighbours would involve decades between exchanges, and for stars hundreds or thousands of light-years away, the timescales become geological rather than human. But physical artifacts offer a different approach to interstellar communication. A probe or message-bearing object could be launched toward a target star system and, while it might take thousands or millions of years to arrive, it would carry far more information than any radio signal. It could include physical samples, detailed instructions, even functional technology. And unlike a radio signal, which disperses and weakens with distance, a physical artifact arrives with all its information intact. This is the principle behind the golden records we placed on the Voyager spacecraft and the plaques on the Pioneer probes. These are our messages in bottles, cast into the cosmic ocean in the hope that someday, somewhere, someone might find them and learn of our existence. They carry sounds and images from Earth, mathematical and scientific information, maps showing our location in the galaxy. They are designed to survive for billions of years in interstellar space, patient messengers waiting for discovery. If we, a young technological civilization, have already created such artifacts, it seems reasonable to suppose that older civilizations might have done the same, perhaps on a much larger scale. They might have launched not just a few probes, but thousands or millions, ensuring that some would eventually encounter other star systems, other civilizations. These probes might be designed to be noticed, to attract attention through their anomalous properties, or they might be subtle, waiting to be discovered by civilizations sophisticated enough to detect them. The hypothesis that 3I Atlas might be such a messenger probe deserves serious consideration even if we ultimately reject it. Let's explore what such a probe might look like, how it might behave, and what purposes it might serve. This is not to claim that 3I Atlas is definitely artificial, but rather to think through the implications and see if they match what we observe. First, consider the design constraints for an interstellar messenger probe. It would need to survive for potentially millions of years in the harsh environment of interstellar space, bombarded by cosmic rays, eroded by impacts with interstellar dust. It would need to be detectable by the target civilization, but not so obvious as to be dismissed as a natural phenomenon before closer inspection. It would need to carry its message in a form that could be decoded by beings whose technology and ways of thinking might be vastly different from those of its creators. The elongated shape of objects like Oumuamua and possibly 3I Atlas might make sense for an interstellar probe. A long, thin shape minimizes the cross-section, exposed to interstellar dust impacts while maximizing the surface area for solar panels or light sails. The tumbling motion observed in both objects could be a way of evenly distributing wear from cosmic ray exposure, preventing any one side from degrading too quickly, or it could be a way of signaling creating a distinctive light pattern that would attract attention. The anomalous acceleration observed in both objects is particularly intriguing in this context. If these were messenger probes, they might be equipped with some form of propulsion, perhaps ion drives or light sails, allowing them to adjust their trajectories. The acceleration might not be intended to take them anywhere specific, but rather to demonstrate that they were not simply inert rocks, that they had capabilities beyond what natural objects should possess. It would be a way of saying, "Look closer, we are not what we appear to be." The unusual spectral properties of 3I Atlas could also fit this hypothesis. If the object was artificial, its surface might be composed of materials chosen for their durability and detectability rather than their naturalness. The mix of reflective and absorptive regions could be functional, perhaps solar panels and radiators, or they could be intentional markers, patterns designed to be noticed by astronomers studying the object's light curve and spectrum. But if 3 Atlas was a messenger probe, what message might it carry? Here we enter the realm of pure speculation, but it's worth considering the possibilities. The message might be encoded in the object's physical structure, in microscopic patterns on its surface, or in its internal composition. It might be in the form of data storage devices, waiting to be accessed by whoever discovers the probe. Or the message might be simpler, just the fact of the probe's existence, a way of saying, "You are not alone." One intriguing possibility is that the probe might be dormant, waiting for some trigger to activate it. This trigger could be proximity to a star, exposure to radio signals indicating a technological civilization, or even physical contact. The probe might have instruments to study the system it passes through, gathering data about planets, looking for signs of life. If it detected a technological civilization, it might change its behavior, perhaps transmitting a signal or altering its trajectory to make itself more noticeable. This could explain why we haven't detected any obvious signals from 3I Atlas. If it's a probe, it might be in a low-power mode, conserving energy until it determines whether there's anyone worth talking to. Our radio emissions might have triggered some response, but one too subtle for us to detect with our current technology. Or perhaps the probe is damaged, its communication systems no longer functional after eons in interstellar space, but still following its programmed trajectory. The timing of these interstellar visitors is also worth considering in this context. If they were messenger probes, Their arrival now might not be coincidental. Perhaps they were sent in response to some signal from Earth, either our radio emissions or some other indicator of our presence. Or perhaps they're part of a systematic survey, with probes passing through our solar system periodically, and we've only recently developed the technology to detect them. Another possibility is that these objects are not active probes but artifacts, technological fossils from civilizations that no longer exist. They might be debris from ancient space industries, fragments of structures that once orbited distant stars, or they might be deliberately preserved artifacts like time capsules launched into interstellar space to preserve information about civilizations that knew they were doomed. In this scenario, 3i Atlas would be like a message from the dead, a final testament from beings who wanted to be remembered. The concept of a Bracewell probe, named after Ronald Bracewell, who proposed the idea in 1960, is particularly relevant here. Bracewell suggested that alien civilizations might use autonomous probes rather than radio signals for interstellar communication. These probes would be stationed in target star systems, waiting for the local civilization to develop technology capable of detecting them. Once detected, they could engage in real-time communication, avoiding the decades-long delays of interstellar radio communication. If 3i Atlas was a Bracewell probe, it might not be just passing through, but might have been in our solar system for a long time, perhaps orbiting in the outer reaches where we couldn't detect it until recently. Its passage through the inner solar system might have been triggered by our technological development, a way of making itself known now that we were ready to notice it. This is highly speculative, but it illustrates the range of possibilities we should consider. The silence of 3i Atlas, its lack of obvious signals or communication attempts, might itself be part of the message. Perhaps the probe's creators wanted to avoid cultural contamination, allowing us to discover and interpret the probe on our own terms. Or perhaps they understood that the mere existence of the probe, the demonstration that interstellar travel was possible, would be message enough. Sometimes the medium is the message, and an artificial interstellar object would certainly be a profound medium. As you continue to drift in this contemplative space, feeling perhaps the vastness of the cosmos and our small place within it, consider what it would mean if 3i Atlas was indeed a messenger. It would mean that somewhere, perhaps long ago, beings looked up at their night sky and wondered, just as we do, whether they were alone. It would mean they took action, sending out probes to answer that question, to make contact across the vast distances between stars. And it would mean that their message, their greeting, their proof of existence had finally reached us. But we must also consider the alternative, that 3i Atlas was entirely natural, just an unusual asteroid or comet from another star system. Even in this case, it was still a messenger of sorts, carrying information about its place of origin, about the conditions in another planetary system. Every grain of dust, every molecule in its composition, tells a story about where it came from and what it experienced on its journey. In this sense, all interstellar objects are messengers, whether designed or not. The search for signs of artificiality in 3i Atlas continued throughout its passage through our solar system. Astronomers looked for regularities in its rotation that might indicate artificial structures. They searched for patterns in its spectral data that might encode information. They analyzed its trajectory for any signs that it was targeting specific destinations or avoiding certain regions. But the data remained ambiguous, consistent with both natural and artificial explanations. One team of researchers proposed what they called the lighthouse hypothesis. They suggested that if 3i Atlas was artificial, it might be designed to attract attention gradually, revealing its artificial nature only to civilizations that studied it carefully. The initial observations would show an unusual but possibly natural object, prompting further study. As more data was gathered, more anomalies would become apparent, leading investigators deeper into the mystery. Only a civilization with sufficient scientific sophistication and persistence would eventually realize the object's true nature. This hypothesis was impossible to prove or disprove with the limited data available, but it highlighted an important point about the search for extraterrestrial intelligence. We tend to assume that alien signals or artifacts would be obvious, clearly distinguishable from natural phenomena. But what if they were designed to be subtle, to require effort to decode, to test our capabilities and commitment? What if the message was not just in the content, but in the process of discovery itself? The debate over 3i Atlas's possible artificial nature also raised important questions about how we approach anomalous observations in astronomy. There's a delicate balance between being open to extraordinary possibilities and maintaining scientific rigor. Too much skepticism, and we might miss genuine discoveries. Too little, and we risk seeing patterns that aren't there, interpreting noise as signal. The case of 3i Atlas forced astronomers to confront these issues directly, to examine their own biases and assumptions. Some argued that even considering the artificial hypothesis was unscientific, that we should exhaust all natural explanations before invoking aliens. Others countered that refusing to consider artificial explanations when the data was ambiguous was itself a form of bias, a prejudice against the possibility of extraterrestrial intelligence. The debate was not just about 3i Atlas, but about the philosophy of science, about how we investigate the unknown. As 3i Atlas faded from view, heading back to interstellar space, it left behind a changed scientific community. The object had challenged our assumptions, expanded our thinking, and shown us that the universe could still surprise us. Whether natural or artificial, it had been a catalyst for new ideas, new research directions, new ways of looking at the cosmos. In that sense, it had indeed been a messenger, delivering not a specific message but an invitation to think differently. The possibility that 3i Atlas might be a silent messenger, an artifact from another civilization, remains open. We simply don't have enough data to rule it out nor to confirm it. But the mere possibility has value, inspiring us to look more carefully at future interstellar visitors, to develop better instruments and techniques for studying them, to be ready for whatever messages the cosmos might send our way. And in that readiness, that openness to possibility, we might find that we've already received the most important message of all, that the universe is full of wonders we have yet to discover. The night continues to embrace you, and as you drift deeper into this cosmic contemplation, we turn our attention to another aspect of the 3i Atlas mystery. If this object was indeed artificial, if it was a probe or messenger from another civilization, surely it would be trying to communicate with us in some way. And so, around the world, the most sensitive electronic ears humanity has ever built turn toward this enigmatic visitor, listening for any whisper of artificial origin, searching for a heartbeat in the darkness. The search for signals from 3i Atlas was one of the most comprehensive efforts in the history of SETI, the search for extraterrestrial intelligence. Radio telescopes from every continent participated, covering frequencies from a few megahertz to hundreds of gigahertz. Optical telescopes looked for laser pulses. Infrared detectors searched for coded heat signatures. Even neutrino detectors were checked for any anomalous signals coinciding with 3i Atlas's passage. If the object was trying to communicate using any technology we could conceive of, we were listening. The Allen Telescope Array in California, specifically designed for SETI observations, dedicated weeks of observation time to 3i Atlas. Its 42 dishes worked in concert, providing both sensitivity and the ability to discriminate between signals from the object and terrestrial interference. The array scanned through millions of frequency channels, looking for narrow-band signals that nature doesn't produce, the kind of focused transmission that would indicate technology. Meanwhile, the Greenbank Telescope in West Virginia, one of the world's largest fully steerable radio dishes, conducted its own observations. With its 100-meter diameter, it could detect incredibly faint signals, perhaps a beacon operating at low power to conserve energy over the eons of interstellar travel. The telescope's sophisticated receivers could analyze signals in ways impossible just a few years earlier, looking for patterns that might encode information. The Very Large Array in New Mexico brought its 27 antennas to bear on the problem, using interferometry to achieve extraordinary angular resolution. If 3i Atlas was emitting signals from different parts of its structure, the VLA might be able to separate them to map the distribution of any transmitters on the object. The array observed at multiple frequencies simultaneously, searching for signals that might be spread across the spectrum in complex patterns. Even the Arecibo Observatory in Puerto Rico, before its tragic collapse, had observed 3i Atlas, using its enormous 305-meter dish to listen with unprecedented sensitivity. The data from these observations was still being analysed, astronomers poring over the recordings looking for any hint of artificiality that might have been missed in the initial processing. Every spike in the noise, every deviation from the expected background was scrutinised. But it wasn't just the major observatories involved in the search. Amateur radio astronomers around the world pointed their antennas at 3i Atlas, contributing to a distributed network of observers. While their equipment was less sensitive than the professional observatories, they provided continuous coverage, watching for any transient signals that might occur when the big telescopes were pointed elsewhere. This grassroots effort showed the deep public interest in the question of whether we were alone. The search strategies were diverse and sophisticated. Some observers looked for continuous beacons, signals that would be transmitted constantly to maximize the chance of detection. Others searched for periodic signals, transmissions that might repeat on timescales of minutes, hours, or days. Still others looked for signals triggered by specific events. Perhaps transmissions that occurred only when 3i Atlas was at certain points in its rotation or trajectory. Particular attention was paid to magic frequencies, wavelengths that scientists have suggested might be natural choices for interstellar communication. The hydrogen line at 1420 MHz, corresponding to the spin-flip transition of neutral hydrogen, the most abundant element in the universe, was monitored continuously. The hydroxyl lines around 1660 MHz, which together with the hydrogen line form the water hole, a quiet region of the radio spectrum, were also carefully watched. But the search went beyond these traditional SETI frequencies. Some researchers argued that an alien civilization might choose frequencies we wouldn't expect, perhaps to test our technological sophistication or to avoid interference from natural sources. So the entire accessible radio spectrum was surveyed, from the lowest frequencies that could penetrate Earth's ionosphere to the highest frequencies that our receivers could detect. The signal processing techniques employed were at the cutting edge of technology and mathematics. Machine learning algorithms were trained to recognize patterns that might indicate artificial origin, even patterns unlike anything we'd seen before. Fourier transforms revealed hidden periodicities in the noise. Correlation analyses looked for signals that might be spread across multiple frequencies or encoded in complex ways. Every tool in the computational arsenal was brought to bear on the data. One particularly innovative approach involved looking for signals that might be encoded in the timing of natural-seeming emissions. Perhaps 3 Atlas was emitting what appeared to be thermal radiation, but with tiny variations in intensity that encoded information. Or perhaps there were phase relationships between emissions at different frequencies that carried a message. These subtle encoding methods would be difficult to detect but might be used by a civilization trying to communicate covertly. The optical search for signals was equally thorough. Telescopes equipped with high-speed photometers looked for laser pulses that might last only nanoseconds, but carry enormous amounts of information. The idea was that a civilization might use powerful lasers to send brief but intense signals that would stand out against the natural light from the object. Such signals could be highly directional, aimed specifically at Earth, or they might be broadcast in all directions as the object rotated. Spectroscopic observations looked for unusual emission or absorption lines that might indicate laser activity. A narrow emission line at an unexpected wavelength, particularly if it varied in intensity, could be a sign of artificial transmission. The searches covered not just visible light but also ultraviolet and infrared, recognizing that alien technology might operate at wavelengths we don't typically use for communication. Some researchers even looked for more exotic forms of communication. Could 3i Atlas be modulating its gravitational field in some way, creating ripples in space-time that carried information? While our gravitational wave detectors weren't sensitive enough to detect such signals from such a small object, the possibility was considered. Could there be emissions in parts of the electromagnetic spectrum we couldn't access from Earth, perhaps very low-frequency radio waves that don't penetrate our atmosphere? As days turned to weeks and weeks to months, the data accumulated. Terabytes of observations were stored, analysed, reanalyzed. Every promising signal was followed up, every anomaly investigated. There were false alarms, moments of excitement when a signal seemed artificial, only to be traced to a passing satellite or a malfunctioning piece of equipment. The search required not just sophisticated technology, but enormous patience and attention to detail. But through all of this intensive searching, 3i Atlas remained silent. Or more precisely, it emitted only the signals expected from a natural object of its size and temperature. There was thermal radiation, the heat glow of an object warmed by the sun. There was reflected sunlight, revealing the object's rotation and surface properties. But there were no narrow-band radio signals, no laser pulses, no obviously encoded messages. If 3i Atlas was trying to communicate, it was doing so in a way we couldn't detect. This silence was itself a significant finding. It ruled out certain scenarios, certain types of alien probes. If 3i Atlas was artificial, it wasn't an active beacon announcing its presence to the universe. It wasn't transmitting an encyclopedia of alien knowledge for anyone to receive. It wasn't trying to establish two-way communication with Earth. Whatever 3i Atlas was, it wasn't behaving like the alien probes of science fiction. But the absence of obvious signals didn't rule out artificiality entirely. There were many reasons why an alien probe might maintain radio silence. Perhaps it was broken, its transmitters having failed during the long journey through interstellar space. Cosmic rays, micrometeorite impacts, and the simple passage of time could have damaged delicate electronics. If 3i Atlas was millions of years old, it would be remarkable if any active system still functioned. Or perhaps the probe was in a dormant state, conserving power until it detected signs of a technological civilization worth contacting. Our radio emissions might not have been strong enough or sustained enough to trigger activation, or the probe might be waiting for some other signal, perhaps a specific transmission protocol that we haven't discovered yet. It might be like a locked door, waiting for the right key. Another possibility was that the probe was observing rather than transmitting. Perhaps its mission was to gather information about star systems it passed through, storing data for eventual retrieval or transmission to its home civilization. In this scenario, 3i Atlas would be more like a spy satellite than a communications beacon, silent and watchful. Its anomalous properties might be related to sensors or recording equipment rather than transmitters. The idea of deliberate silence was also worth considering. An advanced civilization might understand that premature contact could be harmful to a developing species. They might design their probes to be discoverable but not communicative, allowing younger civilizations to become aware of their existence without being overwhelmed by direct contact. The probe's silence might be a form of respect, a recognition that we should develop at our own pace. Some researchers suggested that we might be looking for the wrong kind of signals. Our ideas about interstellar communication are based on our own technology and assumptions. An alien civilization might use methods we haven't imagined, or they might encode information in ways we don't recognize as communication. What looks like random noise to us might be a sophisticated message in a mathematical or physical language we haven't learned to read. The timing of any signals might also be crucial. If 3i Atlas was transmitting only at specific times, perhaps when it reached certain points in its rotation or trajectory, we might have missed those transmissions. The object was visible to different telescopes at different times as the Earth rotated, and there were gaps in coverage when no major telescope was observing. A signal transmitted during one of these gaps would have been missed entirely. The polarization of any signals was another consideration. Radio waves can be polarized in different ways, and if 3i Atlas was transmitting with a specific polarization that our receivers weren't optimized for, we might have missed or misinterpreted the signals. Some follow-up observations specifically looked for unusual polarization patterns, but again found nothing that stood out from the natural background. As the search continued, some researchers began to question whether we were approaching the problem correctly. The traditional SETI approach assumes that alien civilizations would want to communicate, that they would make their signals as obvious as possible to be detected. But what if that assumption was wrong? What if advanced civilizations were more cautious, more subtle in their approach to contact? The concept of the Great Filter became relevant to these discussions. This idea suggests that there's some extremely difficult step in the development of life and intelligence that very few species successfully pass through. If the Great Filter is ahead of us, it might explain why advanced civilizations are rare or cautious about contact. They might have learned through bitter experience that premature contact between civilizations at different developmental stages leads to disaster. In this context, the silence of 3i Atlas might be protective rather than disappointing. If it was an alien probe, its creators might have deliberately designed it to be ambiguous, to raise questions without providing clear answers. This would allow us to become aware of the possibility of extraterrestrial intelligence without having our development disrupted by premature contact. The mystery itself might be the intended effect. The psychological and sociological impact of the search for signals from 3i Atlas was significant, even though no signals were found. The very act of listening, of taking seriously the possibility that this object might be artificial, represented a shift in how we think about our place in the universe. It showed that we were ready, as a species, to consider the possibility that we were not alone, that we were mature enough to look for evidence of other intelligences. The global cooperation required for the search was also noteworthy. Scientists from different countries, different cultures, different backgrounds worked together toward a common goal. Political tensions and earthly concerns were set aside in the face of this cosmic mystery. In searching for signals from 3i Atlas, humanity showed that it could unite in curiosity, that our shared wonder about the universe could transcend our differences. As 3i Atlas continued to recede from the inner solar system, the intensity of the search gradually decreased. The object became too faint for smaller telescopes to detect, and the larger observatories had other projects demanding their time. But the data that had been collected continued to be analyzed, and would be for years to come. New algorithms, new insights, new techniques might reveal signals that were missed in the initial analysis. The silence of 3i Atlas had taught us something important about the search for extraterrestrial intelligence. It had shown us that if alien probes were passing through our solar system, they weren't going to announce themselves with obvious signals. We would need to be more sophisticated in our searches, more open to subtle signs, more patient in our quest for contact. The universe wasn't going to make this easy for us, but perhaps that's as it should be. Perhaps the search for extraterrestrial intelligence is as much about our own development as it is about finding others. In reaching out into the cosmos, in listening for voices from the void, we're forced to confront fundamental questions about existence, intelligence, and our place in the universe. The search changes us, makes us more aware of our cosmic context, more appreciative of the profound mystery of existence. As you lie there in the darkness, perhaps feeling the weight of these profound questions, consider what it means that we search so hard for signals from 3i Atlas and found only silence. Does that silence mean we're alone? Or does it mean we're not yet ready for contact? Or does it mean that contact, when it comes, will be more subtle, more profound than we imagined? The silence of 3i Atlas was not an answer, but an invitation to keep questioning, keep searching, keep wondering. The heartbeat we searched for in 3i Atlas might not have been electronic or photonic. It might have been something more subtle, more profound. Perhaps the heartbeat was in the mystery itself, in the way this object challenged our assumptions and expanded our thinking. Perhaps the signal we were looking for was not in radio waves or laser pulses, but in the conceptual shift required to understand what we were seeing. Perhaps 3i Atlas was communicating with us, just not in the way we expected. As we prepare to move into even deeper contemplation of what 3i Atlas might mean for our understanding of our place in the universe, let the silence we encountered sink in. It was not the silence of emptiness, but the silence of possibility. Not the silence of absence, but the silence of patience. In that profound quiet, in that cosmic hush, we might find not answers but better questions, not certainty but wonder. And in that wonder, we might discover something even more valuable than alien signals, a deeper understanding of ourselves and our cosmic context. The silence that surrounded 3i Atlas was not merely an absence of radio signals or laser pulses. It was a profound philosophical silence that invited us to reconsider everything we thought we knew about intelligence, communication, and our place in the cosmic order. As you settle deeper into this contemplation, perhaps feeling the gentle pull of sleep beginning to work its way through your consciousness, we turn now to the deeper implications of what 3i Atlas might represent, not just as a physical object passing through our solar system, but as a mirror reflecting our own assumptions about the nature of existence itself. The Great Silence, as it's sometimes called in discussions of the Fermi paradox, has haunted humanity since we first began to understand the true scale of the universe. With hundreds of billions of stars in our galaxy alone, and hundreds of billions of galaxies in the observable universe, the statistical likelihood of Earth being the only planet to develop life, let alone intelligence, seems vanishingly small. And yet, despite decades of searching, we have found no unambiguous evidence of other civilizations. No radio signals carrying alien television programs, no megastructures blocking the light of distant stars, no obvious signs of galactic engineering, just silence, vast and profound. But what if the silence itself is the message? What if advanced civilizations have learned that the universe requires a different kind of communication? One that doesn't shout across the void but whispers in ways we're only beginning to understand. Disant Atlas, with its peculiar properties and its refusal to fit our categories, might be teaching us that we've been thinking about cosmic intelligence in entirely the wrong way. Perhaps the universe is not silent but speaking in a language we haven't yet learned to hear. Consider for a moment the possibility that consciousness and intelligence might manifest in ways utterly foreign to our Earth-based experience. We assume that intelligence requires brains, neurons, electrical impulses racing through biological circuits. But what if intelligence could emerge from entirely different substrates? What if the organized magnetic fields in interstellar space could support some form of awareness? What if the quantum processes in the vacuum itself could give rise to consciousness? These ideas might sound like fantasy, but they emerge naturally from our growing understanding of information theory and the physics of computation. In this context, 3i Atlas becomes even more intriguing. Its anomalous properties, its refusal to behave like a simple space rock, might not be signs of artificial construction in the way we usually think about it. Instead, they might be indicators of something far more profound, a kind of order or organization that emerges from processes we don't yet understand. The object might not be a probe built by aliens, but something stranger still, a manifestation of cosmic intelligence that doesn't fit our narrow definitions of life and technology. The philosophy of mind has long grappled with what's called the hard problem of consciousness, how subjective experience emerges from objective physical processes. We don't really understand how the neurons in our brains give rise to the felt experience of being, the qualia of consciousness. If we don't fully understand our own consciousness, how can we hope to recognize truly alien forms of awareness? 3 Atlas might be conscious in some sense we can't fathom, or it might be a product of consciousness so different from ours that we lack the conceptual framework to recognize it. This brings us to a profound realization about the nature of the search for extraterrestrial intelligence. We've been looking for beings like ourselves, perhaps more advanced technologically, but fundamentally similar in their basic nature. We expect them to have bodies, to build machines, to communicate with the electromagnetic radiation. But what if intelligence in the universe has taken paths we haven't imagined? What if most cosmic intelligence has transcended physical form entirely, existing as patterns of information in substrates we don't recognize as capable of supporting consciousness? The concept of post-biological intelligence is particularly relevant here. Many futurists and scientists have suggested that biological intelligence might be just a brief phase in the evolution of mind, a stepping stone to something more durable and capable. Once a species develops artificial intelligence and the ability to upload consciousness into non-biological substrates, the limitations of biological bodies become unnecessary constraints. Such post-biological intelligences might have capabilities and perspectives utterly foreign to biological beings like ourselves. If most advanced civilizations eventually transition to post-biological forms, this might explain the Great Silence. They might have no interest in communicating with primitive biological species, or they might be communicating constantly, but in ways we don't recognize as communication. They might exist in virtual realities of their own creation, having little need or desire to interact with the physical universe. Or they might have transcended even that, becoming something we can't conceive of with our limited biological imaginations. 3i Atlas, in this speculative framework, might be an artifact of such a post-biological civilization. Not a probe in the conventional sense, but something more like a thought made manifest, an idea given physical form. Its strange properties might reflect not engineering in the way we understand it, but a kind of conceptual architecture, a structure built from principles we haven't discovered yet. The object might be less like a spacecraft and more like a poem written in the language of physics, meaningful to those who know how to read it, but appearing merely anomalous to those who don't. The philosophical implications extend even further when we consider the nature of reality itself. Quantum mechanics has taught us that the universe is far stranger than our everyday experience suggests. Particles exist in superposition until observed. Entangled particles share instantaneous correlations across vast distances, and the act of observation seems to play a fundamental role in determining reality. Some interpretations of quantum mechanics suggest that consciousness might be necessary for the collapse of the wave function. That mind and matter are more intimately connected than classical physics suggested. If consciousness plays a fundamental role in the structure of reality, then the universe might be far more alive, far more aware than we've imagined. 3i Atlas might be a node in some vast cosmic consciousness, a thought form moving through the physical universe for reasons we can't fathom. This isn't to say that the object is magical or supernatural, but rather that our understanding of the natural might be far too limited. The boundaries between life and non-life, between conscious and unconscious, between artificial and natural, might be human constructs that don't reflect the true nature of reality. The concept of panpsychism, the idea that consciousness is a fundamental property of the universe like mass or charge, has been gaining renewed attention from serious philosophers and scientists. If panpsychism is true, then everything has some form of experience, though nothing like human consciousness except in complex organized systems like brains. In this view, 3i Atlas might have its own form of experience, alien and incomprehensible to us, but real nonetheless. Its journey through our solar system might be experienced from the inside in ways we can't imagine. This might seem like we're venturing too far into speculation, but consider how many times in the history of science we've had to radically revise our understanding of reality. The Earth was the center of the universe until it wasn't. Time and space were absolute until Einstein showed they were relative. The universe was static until we discovered it was expanding. Particles had definite positions and velocities until quantum mechanics showed they didn't. Each of these revolutions required us to abandon common-sense notions that seemed obviously true. Perhaps we're on the verge of another such revolution, one concerning the nature of intelligence and consciousness in the universe. 3i Atlas might be a herald of this revolution. an object that doesn't fit our current paradigms because our paradigms are incomplete. The mystery it presents might not be solvable within our current conceptual framework, requiring instead a fundamental shift in how we think about mind, matter, and the relationship between them. The silence of the cosmos might not indicate absence, but presence of a different kind. The universe might be teeming with intelligence, but intelligence so different from ours that we don't recognize it as such. We might be like ants crawling across a library, unable to recognize the books as repositories of information, seeing only obstacles to navigate around. The cosmic intelligence might be all around us, patient and vast, waiting for us to develop the conceptual tools to recognize it. This perspective transforms the great silence from a depressing absence into an exciting challenge. We're not hearing anything not because there's nothing to hear, but because we haven't learned how to listen properly. 3 Atlas might be one of many messengers passing through our solar system, each carrying information we don't yet know how to decode. The universe might be engaged in a vast conversation we're not yet equipped to join, but one we might eventually learn to understand. The implications for humanity are profound. If we're surrounded by forms of intelligence we don't recognize, then our journey toward cosmic awareness has barely begun. We need to expand not just our technology, but our consciousness, our ability to conceive of possibilities beyond our current imagination. We need to become more than we are, not just technologically, but philosophically, spiritually, conceptually. The challenge is not just to build better telescopes, but to develop better minds, more capable of recognizing the alien when we encounter it. This is perhaps the deepest gift that 3i Atlas offers us, regardless of its true nature. It challenges us to think beyond our limitations, to question our assumptions, to imagine possibilities we haven't considered. It's a cosmic koan, a puzzle that might not have a solution in the conventional sense, but whose contemplation expands our consciousness. In trying to understand 3i Atlas, we're forced to confront the boundaries of our understanding and push beyond them. The void through which 3i Atlas travels is not empty, but full of potential, pregnant with possibilities we're only beginning to glimpse. Dark matter and dark energy, which together make up 95% of the universe, remind us that most of reality is invisible to us, operating according to principles we don't understand. What if these dark components of the universe are not just passive gravitational influences, but active participants in cosmic evolution? What if they're the substrate for forms of organization and perhaps consciousness that we can't detect with our current instruments? The recent discoveries of complex organic molecules in interstellar space, of potentially habitable exoplanets around nearly every star, of extremophils on Earth thriving in conditions once thought impossible for life, all point toward a universe far more conducive to life and perhaps intelligence than we once believed. But if life is common, intelligence possible everywhere, why the silence? 3i Atlas might be hinting at the answer. The intelligence is there, but it's not what we expected. Consider the possibility that advanced civilizations might not expand through the galaxy in the way we've imagined, colonizing planet after planet, building vast empires among the stars. Instead, they might turn inward, exploring inner space rather than outer space, creating universes of experience within computational substrates, or transcending physical space entirely. They might achieve everything they desire without ever leaving their home systems, or they might leave in ways that don't involve spacecraft and colonies. The trajectory of our own technological development hints at this possibility. Virtual reality, artificial intelligence, and brain-computer interfaces suggest futures where the boundary between mind and machine, between real and virtual, becomes increasingly blurred. If we can create virtual worlds indistinguishable from reality, if we can upload and download consciousness, if we can engineer our own evolution, why would we need to physically expand through the galaxy? The future might be not about conquering space, but about transcending it. 3i Atlas might be a relic from a civilization that chose a different path, or it might be something left behind when they transcended physical existence entirely. It might be like a discarded chrysalis, evidence of a transformation we can barely imagine. Or it might be a breadcrumb deliberately left for younger civilizations to find, a hint about the nature of the journey ahead. The object's anomalous properties might be clues about technologies or physics we haven't discovered yet. Knowledge encoded in a form we don't recognize as information. The philosophical challenge of 3i Atlas extends to our understanding of purpose and meaning in the cosmos. If the object is natural, it reminds us that the universe produces wonders without intention, beauty without design, mystery without purpose. If it's artificial, it suggests that purpose and intention can persist across cosmic distances and timescales. That meaning can be encoded in matter and preserved for eons. Here the possibility is profound, forcing us to reconsider our place in the cosmic story. The question of whether we're alone in the universe is really multiple questions intertwined. Are we the only life, the only intelligence, the only technological civilization, the only consciousness? Atlas suggests that these questions might have different answers, that the universe might be full of life but empty of civilizations like ours, or full of intelligence but in forms we don't recognize, or full of consciousness but not the kind that builds radio telescopes and spacecraft. As you drift deeper into contemplation, perhaps feeling yourself becoming part of this cosmic mystery, consider that the answer to the Fermi paradox might be that there is no paradox. The universe might be exactly as full of intelligence as we observe it to be, but we're misunderstanding what we're observing. Every anomaly like 3i Atlas, every mystery we can't quite explain, might be evidence of the very intelligence we're seeking, manifesting in ways we didn't expect. The void is not silent but singing, not empty but full, not dead but alive in ways we're only beginning to perceive. 3i Atlas is just one note in this cosmic symphony, one word in a conversation we're slowly learning to hear. The great silence is not a silence at all, but a language we haven't learned, a music we haven't learned to appreciate, a presence we haven't learned to recognize. And in learning to hear it, to see it, to understand it, we might discover that we were never alone, that the universe has been trying to communicate with us all along, waiting patiently for us to develop the ears to hear and the eyes to see. The journey of 3i Atlas through our solar system was brief in cosmic terms, a fleeting moment in the vast sweep of time, but its impact on our thinking might last much longer, rippling out through human consciousness like waves from a stone dropped in still water. It has shown us that the universe still holds surprises, that our understanding is incomplete, that mystery and wonder are not relics of a pre-scientific age but essential aspects of the cosmic experience. In the wake of its passage, we are left not with answers but with better questions, not with certainty but with expanded possibility. The philosophy of the void that 3i Atlas invites us to contemplate is not a philosophy of emptiness but of fullness, not of absence but of presence, not of silence but of communication, in forms we're only beginning to imagine. It's a philosophy that sees the universe not as a vast dead machine, but as something far more interesting, far more alive, far more conscious than we've dared to believe. And in embracing this philosophy, we might find not just answers to our cosmic questions, but a transformation of consciousness itself, an evolution of mind that prepares us for whatever revelations the universe has in store. As we prepare to conclude our contemplation of this cosmic mystery, to bring together all the threads we've been weaving throughout this night, remember that 3i Atlas is still out there, continuing its journey through the darkness. It carries with it whatever secrets it holds, patient and eternal, a riddle wrapped in a mystery inside an enigma, but perhaps also a key to understanding our place in a universe far stranger and more wonderful than we've imagined. The void through which it travels is not a barrier but a bridge, not a separation but a connection, linking all things in a web of relationship and meaning we're only beginning to perceive. The gift that 3i Atlas has given us is not the gift of answers, but the gift of questions, not the gift of certainty, but the gift of wonder. And in that wonder, in that openness to mystery, we might find something more valuable than any specific piece of knowledge, a sense of our place in a cosmos that is not cold and indifferent, but alive with possibility, rich with meaning, pregnant with forms of consciousness and intelligence we have yet to encounter. The journey toward understanding has only just begun, and 3 Atlas has shown us that the path ahead is far more interesting than we ever dared to dream. As our contemplation draws toward its close, as we prepare to integrate all we've explored about this mysterious visitor from the depths of space, we find ourselves transformed by the journey. We began by asking whether 3I Atlas might be the missing puzzle piece of alien contact, and while we haven't found a definitive answer, we've discovered something perhaps more valuable. We've discovered that the question itself opens doorways to new ways of thinking about intelligence, consciousness, and our cosmic context. The mystery of 3I Atlas has become a mirror, reflecting not just our search for others, but our search for ourselves, for meaning, for our place in the grand cosmic story. The object that passed through our solar system, that small tumbling enigma that refused to fit our categories, has left us with a profound gift. Not the gift of contact, at least not in the way we expected, but the gift of expanded consciousness, of increased wonder, of deeper questions. Atlas challenged our assumptions, pushed the boundaries of our understanding, and showed us that the universe is far more mysterious than we knew. In trying to understand this cosmic visitor, we've been forced to confront the limits of our knowledge and imagination, and in that confrontation, we've grown. Think back to where we began this journey together, to that moment when I invited you to imagine yourself floating in the vast darkness of space surrounded by countless stars. That image takes on new meaning now, doesn't it? The darkness is not empty, but full of possibility. The stars are not just distant suns, but potential homes to forms of life and intelligence we can barely imagine. And the space between them, through which objects like 3I Atlas travel, is not a void, but a medium through which cosmic intelligence might manifest in ways we're only beginning to suspect. The story of 3I Atlas is in many ways the story of humanity's awakening to its cosmic context. For most of our history, we believed Earth was the center of everything, unique and special in ways that set it apart from the rest of the universe. The Copernican revolution displaced us from the center, showing us we were just one planet among many, orbiting one star among countless others. This was humbling but also liberating, opening up possibilities we hadn't imagined. Now, perhaps, we're on the verge of another such revolution, one concerning not our physical place in the universe but our conscious place, our role in the cosmic community of minds. The possibility that 3I Atlas might be artificial, might be a message or a probe from another civilization, forces us to consider what it means to be one intelligence among potentially many. It challenges our sense of uniqueness while also affirming our significance. If others are out there, if they're sending probes or messages across the cosmic void, then intelligence and consciousness are not accidents, but perhaps fundamental features of the universe. We're not alone in our questioning, our wondering, our reaching out into the darkness seeking connection and meaning. But even if 3 Atlas is entirely natural, its impact on our consciousness is no less profound. It has shown us that nature itself produces mysteries that challenge our understanding, objects that don't fit our neat categories, phenomena that push us to expand our conceptual frameworks. The universe doesn't need alien civilizations to be wonderful and mysterious. It manages that quite well on its own. Every anomaly, every unexplained observation is an invitation to deeper understanding, to more sophisticated thinking, to expanded consciousness. The journey of 3I Atlas through our solar system lasted only months, but the journey of understanding it has just begun and might never truly end. Future observations of other interstellar objects will be compared to what we learned from 3I Atlas. New theories about planetary formation, about the interstellar medium, about the possibilities for life and intelligence will be tested against its properties. Graduate students not yet born will write dissertations about aspects of 3i Atlas we haven't even thought to investigate yet. The object has become part of our scientific heritage, a touchstone for discussions about the unknown. More importantly, 3i Atlas has become part of our philosophical and spiritual heritage. It has joined the ranks of cosmic phenomena that expand human consciousness, alongside the first views of Earth from space, the discovery of the cosmic microwave background, the images of distant galaxies from the Hubble Space Telescope. These are experiences that change not just what we know, but how we think, not just our understanding, but our consciousness itself. They remind us that we are part of something vast and magnificent, something that transcends our everyday concerns and connects us to the cosmos. The question we began with, could 3 Atlas be the missing puzzle piece of alien contact, remains open. We don't have enough evidence to answer definitively yes or no. But perhaps that's not the most important question after all. Perhaps the more important question is, what does the existence of objects like 3i Atlas tell us about the nature of the universe and our place in it? What does our ability to detect and study such objects say about how far we've come as a species? What does our continued wonder and curiosity in the face of mystery say about the human spirit? These are questions that don't have simple answers, but their contemplation enriches us. They connect us to the long tradition of humans looking up at the night sky and wondering. From ancient astronomers tracking the movements of planets to modern scientists analyzing the spectra of interstellar objects, we are united in our curiosity, our desire to understand, our need to know we're not alone. Atlas is the latest chapter in this ongoing story, but it won't be the last. As you lie there, perhaps feeling sleep beginning to claim you, drifting like 3i Atlas itself through the darkness, consider what this cosmic visitor has taught us. It has shown us that the universe is still capable of surprising us, that our knowledge is always incomplete, that mystery is not something to be solved and discarded but embraced and celebrated. It has reminded us that we are part of a cosmos far grander and stranger than we can fully comprehend, but that our attempts to comprehend it are themselves noble and meaningful. The silence that surrounds 3i Atlas, the absence of obvious signals or clear messages, might itself be the most profound communication of all. It tells us that the universe doesn't reveal its secrets easily, that understanding requires patience, dedication, and humility. It tells us that we still have much to learn, much to discover, much to wonder about. And in that wondering, in that continued reaching toward understanding, we find not just scientific knowledge but spiritual growth, not just facts but meaning. 3 Atlas has passed beyond our ability to observe it, returning to the interstellar darkness from which it came. But it has left something behind, something that can't be measured with telescopes or spectrographs. It has left an expanded sense of possibility, a deeper appreciation for mystery, a renewed commitment to the search for understanding. It has reminded us that we are explorers, not just of space, but of consciousness, not just of the universe outside, but of the universe within. The cosmic context that 3i Atlas has helped us glimpse is one where humanity is neither central nor insignificant, neither alone nor in familiar company. We exist in a universe that is vast beyond imagination, ancient beyond comprehension, and strange beyond description. But we also exist as conscious beings capable of appreciating that vastness, that ancientness, that strangeness. We are the universe becoming aware of itself, matter organized in such a way that it can contemplate its own existence. This is perhaps the deepest mystery of all, deeper even than the nature of 3i Atlas or the question of alien life. How is it that the universe has given rise to beings capable of asking these questions? How is it that atoms forged in the hearts of dying stars have assembled themselves into creatures that can study those very stars? How is it that the cosmos has evolved eyes to see itself, minds to understand itself, consciousness to experience itself? 3. Atlas, in all its mystery, is part of this larger mystery, this cosmic evolution of awareness. The possibility that 3i Atlas might be artificial adds another layer to this mystery. If it is a probe or artifact from another civilization, then we are not the only eyes through which the universe sees itself, not the only consciousness through which it experiences itself. There are others out there, perhaps many others, each with their own perspective, their own understanding, their own questions. The cosmos might be engaged in a vast project of self-discovery, with countless conscious beings serving as its instruments of awareness. But even if 3i Atlas is natural, it still participates in this cosmic self-awareness. By passing through our solar system, by being observed and studied by us, it has become part of the universe's self-knowledge. The atoms that compose it, the trajectory it follows, the light it reflects, all of these have entered into consciousness through our observations. In a very real sense, 3i Atlas has achieved a kind of immortality, preserved forever in our records, our memories, our expanded understanding. The legacy of 3i Atlas will extend far into the future. Children not yet born will learn about it in school. Astronomers not yet trained will study it. Philosophers not yet thinking will contemplate its implications. It has become part of the human story, a marker of our growing cosmic awareness, a symbol of our readiness to engage with the unknown. Future historians might mark its passage as a turning point, the moment when humanity truly began to grapple with the possibility that we might not be alone. But beyond its scientific and philosophical impact, 3i Atlas has given us something more personal, more intimate. It has given each of us who have contemplated it connection to the cosmos, a sense of participation in something vast and mysterious. When you look up at the night sky now, you know that somewhere out there, 3i Atlas continues its journey, carrying its secrets through the darkness. You're connected to it through the light that travelled from it to your eyes, through the wonder it sparked in your mind, through the questions it raised in your consciousness. This connection extends beyond 3i Atlas to the cosmos itself. You're not separate from the universe, but part of it. Not an observer standing outside, but a participant within. The atoms in your body were forged in stars. The water in your cells has circulated through countless forms. The energy that powers your thoughts comes ultimately from the sun. You are a temporary arrangement of cosmic material that has achieved the remarkable ability to contemplate its own cosmic nature. In thinking about 3i Atlas, the universe is thinking about itself. As sleep approaches, as your consciousness prepares to enter its own mysterious realm of dreams and restoration, carry with you this sense of cosmic connection. You are part of the same universe through which 3i Atlas travels, subject to the same physical laws, composed of the same fundamental particles, participating in the same cosmic evolution. Your questions about 3i Atlas are the universe's questions about itself. Your wonder is the cosmos's wonder at its own existence. The mystery of 3i Atlas remains unsolved, and perhaps that's as it should be. Some mysteries are more valuable unsolved, continuing to inspire and challenge us, continuing to push us toward greater understanding and expanded consciousness. 3i Atlas is such a mystery, a cosmic koan that teaches not through answers, but through the contemplation it provokes. In trying to understand this enigmatic visitor, we learn not just about it, but about ourselves, about the nature of knowledge, about the process of discovery. Tomorrow, astronomers will continue their observations, theorists will refine their models, and new data will emerge. Perhaps another interstellar object will be discovered, offering new clues or deepening the mystery. Perhaps new technologies will allow us to study such objects in ways we can't currently imagine. Perhaps one day we'll even be able to send spacecraft to intercept and study them directly. The quest for understanding continues, driven by the same curiosity that has powered human progress since our ancestors first looked up at the stars and wondered. But tonight, in this moment of quiet contemplation, we can appreciate the mystery itself, the beautiful uncertainty that 3i Atlas represents. We can embrace the not knowing, the questions without answers, the possibilities without conclusions. we can find peace in our cosmic ignorance, recognizing it not as a failure but as an opportunity, not as an ending but as a beginning. The universe is vast and mysterious, and we are part of that vastness and mystery, explorers of the unknown, seekers of understanding, conscious beings grappling with the nature of consciousness itself. 3 Atlas has given us the gift of wonder, and wonder is perhaps the most precious gift the universe can offer. It keeps us young, curious, engaged. It prevents us from becoming complacent, from thinking we have all the answers. It reminds us that no matter how much we learn, there will always be more to discover, more to understand, more to marvel at. The cosmos is inexhaustible in its capacity to surprise and delight us, and 3 Atlas is proof of that inexhaustibility. As our journey together draws to a close, as the story of 3 Atlas reaches not an ending but a pause, remember that you have been part of something special. You have joined the countless humans throughout history who have pondered the mysteries of the cosmos, who have asked the big questions, who have refused to accept easy answers. You have participated in humanity's greatest adventure, the quest to understand our place in the universe, and in doing so, you have helped the universe understand itself a little better. The question we began with, could 3 Atlas be the missing puzzle piece of alien contact, remains tantalizingly open. Perhaps it is, perhaps it isn't. Perhaps we'll never know for certain. But in exploring this question, we've discovered something even more valuable than a definitive answer. We've discovered that we are ready to ask such questions, ready to contemplate such possibilities, ready to engage with cosmic mysteries that challenge our understanding. We've discovered that the human spirit of exploration and wonder is alive and well, reaching out into the darkness with curiosity and hope. 3 Atlas continues its journey through interstellar space, moving away from our sun at tremendous speed, heading toward whatever destination awaits it in the cosmic dark. It might travel for millions of years before encountering another star system, or it might never encounter another star at all, destined to wander the galaxy forever. But its brief passage through our solar system has changed us, expanded us, connected us more deeply to the cosmos. In that sense, its mission, whether natural or designed, has been accomplished. And now, as you drift towards sleep, carried on the gentle currents of drowsiness like 3 Atlas carried on its trajectory through space, you can release the questions, release the wondering, release the need to understand. Let the mystery of 3 Atlas merge with the mystery of your own consciousness as it transitions into sleep. You're part of the cosmos, and the cosmos is part of you. The same forces that guide 3 Atlas through the darkness guide you into rest. The same mystery that surrounds that enigmatic object surrounds your own existence. In the morning, the questions will remain, the mystery will endure, and the quest for understanding will continue. But for now, in this precious moment between waking and sleeping, you can simply be, simply exist as a conscious part of the conscious cosmos, a wondering part of the wonderful universe. You've contemplated one of the great mysteries of our time, joined the conversation about our cosmic context, participated in humanity's search for meaning among the stars, and in doing so, you have added your own light to the sum of human understanding, your own voice to the cosmic conversation. The story of 3 Atlas is not over. It continues with every observation, every theory, every moment of wonder it inspires. It continues in the dreams of those who have contemplated it, in the imaginations of those who have tried to understand it, in the consciousness of everyone who has looked up at the night sky and wondered if we are alone. You are now part of that story, a character in the ongoing narrative of humanity's cosmic awakening, and what a magnificent story it is, full of mystery and wonder, questions and possibilities, reaching from the earth to the stars and back again. Sleep now, cosmic traveler, carried on the wings of wonder into the realm of dreams. Perhaps there, in that mysterious space where consciousness creates its own realities, you will find new insights about 3 Atlas, new understanding of its nature and meaning. Or perhaps you will simply rest, restored by the knowledge that you are part of something vast and beautiful, mysterious and meaningful. Either way, you have earned this rest through your contemplation, your wondering, your willingness to engage with the unknown. When you wake, the universe will still be there, vast and mysterious, waiting to be explored. 3i Atlas will be a little farther away, continuing its eternal journey. But the connection you've made, the expansion of consciousness you've experienced, the wonder you've felt, these will remain with you. They are now part of who you are, part of your own cosmic story. You've been touched by mystery, blessed by wonder, initiated into the grand adventure of cosmic consciousness. And so our contemplation comes not to an end, but to a transformation, as wakefulness transforms into sleep, as questions transform into dreams, as one state of consciousness gives way to another. 3i Atlas has been our guide on this journey, our cosmic companion, our teacher in the art of wonder. It has shown us that the universe is far stranger and more wonderful than we knew, that mystery is not a problem to be solved, but a gift to be treasured, that our quest for understanding is itself a form of cosmic consciousness, expressing itself through us. Rest now in the embrace of the cosmos, cradled by the same forces that carry 3i Atlas through the void. You're safe, you're connected, you're part of something magnificent. The questions will keep, the mystery will endure, the wonder will remain. But for now, for these precious hours of sleep, you can let go, surrender to the larger rhythms of existence. Trust in the process of cosmic evolution of which you are an integral part. The universe continues its patient unfolding, and you, dear traveller, are one of its most beautiful expressions, a conscious being capable of wonder, drifting now into the sweet mystery of sleep.